Hello, hi, namaskar everyone. Give me a quick response if I'm clearly visible and audible. Shall we get started everyone? Shall we? I hope I'm clearly visible and audible. You can see the screen right there in front of you and the video is running smoothly right there in front of you. Give me a quick response if I'm clearly visible and audible. Students, do let me know if there is any confusion. I hope there are no concerns, queries or doubts so far regarding anything. I was just fixing the audio issue, so I hope it is resolved now and I'm clearly visible and audible. Great, 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 great. So with this, let's get started everyone. Just give me a quick response if I'm clearly audible and visible, everybody. Hold on for a while. Let me just fix few things. So here we are, everybody. Shall we get started? Are you all there? With this, sir, what are we exactly doing? We are starting the trigonometric functions and equations. It is not merely trigonometric functions and equations, it is trigonometric ratios, trigonometric identities, trigonometric functions, trigonometric equations, and a lot more. So, sir, what exactly is this? This is first of all a one shot. Sir, one shot of this whole chapter? Yes. So, sir, what are we going to do here in this session? In this session, we'll cover this whole chapter. Okay, sir, we get it. But is this one shot enough or sufficient? First of all, no. Then who is this one shot for actually? This one shot is right now specifically for our Arjuna batch students. So anybody who is in 11th standard has joined us Arjuna batch. In Arjuna batch, they have this chapter as a backlog and we are covering it here, which means all the recorded lectures are there. They can watch it anytime. But with this one shot also, they can cover it totally, absolutely and completely. Yes, you heard me right. So I repeat, this is a backlog series which we have started, and in this backlog series, today we are covering trigonometric ratios, identities, functions and equations and everything related to trigo. Before we get started, I hope you do know that here, so far in this backlog series, we have covered the chapters such as sets, we have covered relations and functions. We indeed have covered the previous chapter in the last class, yesterday only, quadratic equations. And today we will do trigo, equations and functions. Okay, sir, we get it. So will you get this whole chapter covered? No, nothing is dropped, nothing is stopped, everything is going on. We have something as an urgent coming up, so we are covering it first, and then that series for class 12 standard students will continue as it was from the next week onward. Don't worry about that, Dinesh, my friend. I repeat, here we are with this backlog series, and today we are covering trigonometric functions and equations. Sir, what I'll be covering here is, sir, can I watch this for class 11 school exams? Of course you can, if you find it interesting, if you find it understandable, if you find it something which is adding inputs to your board level knowledge as well, of course you can. What's wrong in that? But do ensure that I'll be covering some JEE levels concept as well. So don't you get confused with those if you are specifically preparing for boards. Anyways, students, sir, will this one shot be enough for JEE preparation of trigo? Absolutely not. Totally not. Sir, then why should we watch this one shot? If you want to understand the chapter, if you want to understand the concept, if you want to understand the theory, if you want to learn all the formulae, identities and everything, this one shot is there for you. But if you want to strengthen it, consolidate it, want to make this chapter better, then I'll say after watching this one shot, you should practice a lot of questions, depending on what kind of preparation you're doing. So if you are genuinely want to get better at this chapter, practice of last 6 years JEE Mains PYQs is highly advised or recommended. Definitely, my friend Jeevan, you can, you should, you absolutely should. So what are we going to do? I hope we'll first of all begin our discussion with angles. Then we'll talk about radians and degree conversion. Absolutely. That all is covered in our strategy videos, my friend. If you visit our channel, in the videos section, a lot of strategy videos we have provided. If you watch those, you will definitely get help from those. Anyways, if you really want a strategy video on this, I'll create one. That how can you prepare for JEE Mains and Advanced without coaching? What all resources, what all material, what all timetable, what all books, what all strategies, Everything I'll cover in that video, don't worry. But Bhardwaj, can you be more specific regarding your stage? Where do you stand right now? You are in 11th, you are in 12th, you are a dropper. Where actually you are? So that if you are more specific, I'll be in a better position to address this issue. By the way, coming back to this discussion, then we'll begin with some basic identities and trigonometric ratios. We'll of course talk about these graphs, sine, cos, tan, cosec, sec, cot. And of course, we'll talk about the standard identities which you have started studying from 10 standard days. And trust me, I will indeed extend those identities only, which will get converted into all those identities which you study in 11th, 12th standard while preparing for either boards or JEE. Yes, we'll cover all of those as well. Not just that, a lot of identities we'll study today, sum based, multiplication based, transformation based, double angle, half angle, triple angle, a lot of identities we'll study today. So those will get covered first of all. And then, good evening Vijay, good to have you. And then we'll talk about maximum and minimum value of a function. We'll learn how do we solve trigonometric equations, and we'll also learn how do we solve trigonometric inequations, and we'll also learn how do we solve equations based questions by using graphs. But before everything else, if I could simply tell you what is an angle, can you quickly tell me what do you really understand by an angle? Sir, angle, if you want to understand, let's say I have this as a line, and there is another line. So this line I call in initial position. This is the initial position of this line. And when I rotate this line, this reaches into this final position. This reaches into its final position. So this initial to final, I have rotated it in anti-clockwise direction by certain degrees. Let's call it 30 degree. So here the measurement of this angle, from here, initial to final, it happens in anti-clockwise direction. I hope initial to final, to reach to final from initial, I am moving in which direction? Anti-clockwise direction. So if I'm moving in anti-clockwise direction, I am clearly treating this angle as positive. So what do you mean? Angles are also positive and negative? Yes. For example, let's say here you have this initial position of a line, and inclination of this line with respect to this line you are measuring, and here you are rotating by 45 degrees in clockwise direction. This is the initial position, this is the final position. So inclination of this line with respect to this line, you measuring it in the clockwise direction, because from initial to final, you rotate it clockwise. And if the rotation is happening in the clockwise direction, this angle will not be read simply as 45 degree. Magnitude wise, the angle is 45 degree. But if you observe the direction as well, whether clockwise or anti-clockwise, it is clockwise, and because of that, it will be minus 45 degree. Yes, Mr. Bhardwaj, I'll address that very soon, but you visit our videos section and watch all the strategies videos. You'll definitely get some help. Good evening, everyone. Good evening from Tamil Nadu, from Andhra, from Telangana, from Karnataka, from Kerala, from Odisha, from Bengal, from Assam, from Himachal, from out of India, wherever you are, from whichever class you are. Good evening, everyone. Good to have you all. Thank you so much for being here. Now, coming back to this discussion, first of all, did you understand the concept of angles? Everybody, yes or no? Now, in this concept of angle, one very basic philosophy gets added, that sir, angles we usually read in degrees. For example, we say that one complete revolution if you make, this complete revolution you call a rotation, one rotation you call 360 degree. Yes, it is 360 degree. So sir, why we take it as 360 degree? Why not 100 degrees? Why not some other good number? For example, we say 100 meters, 100,000 meters. So numbers are good in terms of higher powers of 10. But here you are taking it as 360 degree. Why specifically like 360 degrees? We could have taken it as some other value as well. Yes. And that was taken actually. The unit was called grade. So along with degree, French mathematicians developed a unit grade. So in grade, you see one grade is equals to 100 units of subunits of it. So there the problem was, I think 100 degree is was, or I think 100 grades was 1 degree. I don't remember exactly, because it got obsolete, it got outdated. Sir, why? Because it is not very useful unit. Sir, why? 360 is a number which is divisible by 2, which is divisible by 3, 5, 6. It has a lot of factors. where that grade unit did not give you that flexibility there. So with the degrees, whenever we talk about Earth, its revolution around Sun, and a lot of results when we talk about, they all were setting, getting settled around this number in a more better manner. The calculation was easier when it was a multiple of 6 or 60. So that's why degrees are more useful in terms of measuring the angles, and 360 degree is treated as one revolution or one complete rotation. Everybody getting this? Everybody understanding this? Sir, can you teach binomial theorem full topic tomorrow? This is not a tuition, my friend. I would love to if you were here and if I was just teaching you. But we treat the whole audience as one and we address the major concern, majority of the audience problem. So I repeat, this is a backlog series, my friend. Backlog series means here we are having our students enrolled in the Arjuna batch who may have joined us a little late, where we have already covered some chapters like sets, relations and functions, quadratic equations, trigonometric functions, equations, and those chapters they have missed. So with these one-shots, we are trying to help them cover these chapters. That's the intent. Do you get my point, my friend? Anyways, very soon in the future, not just tomorrow, it's a huge demand, by the way. Very soon in future, we'll do all the chapters of 12th as well, all the chapters of 11th as well from IIT JEE mains and advanced perspective. Although some chapters of 12th standard we have already done, and very soon we'll resume that from the next week onward. Coming back to the discussion. So first of all, are you understanding the degree measurement? Now in this degree measurement, there was this radian measurement. Sir, what is radian measurement? In radian measurement, what happens is, please pay attention everyone, if you have this circle, which has its center and radius. So if you measure an arc, equal, I'm really sorry. If you measure an arc equal to length of its radius, let's say this is the length of its radius. So this arc would be subtending some certain angle at its center. Yes. So can I measure this angle? Yes. So can you help me by writing your answer in the comments? What is the relation between a circle's radius and the length of the arc and the angle subtended by this length of the arc L at the center circle C having radius R? Can you help me with the formula? Anybody? I hope all of you, most of you are aware of it. You must have studied, I think, it in 9th or 10th standard, where you say that said theta is L upon R. Now, mind you students, you may be or you might be using it incorrectly, that theta is in degrees. That's a problem. No. When you solve this, when you put the length of the arc, when you put the radius of the circle, and when you take this ratio, it is not in degrees. The theta you actually get by solving this formula is in radians. Absolutely. That's brilliant, student. Keep it up. L by R. That's brilliant. So, sir, what do you mean by radians? Okay. I am saying for a while, let's say the length of this arc is equal to the radius of this circle. Absolutely, it is radian. Let's say for a while, the length of this arc is equal to the radius of this circle. What happens then? I hope you do realize in that case, sir, theta will be L by R, but L is R, so it will be R by R, which is 1. Theta is 1. Which one or what one? 1 degree or 1 radian? As I have already told you that it is not 1 degree, it is 1 radian. So if it is 1 radian, do you realize the measurement of 1 radian? So whenever I talk about an angle, and if I don't mention any unit on it, for example, if I have 1 degree, I'll write it like this. If I have 1 radian, I'll write it like this. Or if I have 1 radian, I'll write it like solely as 1 as well. So if no unit is mentioned, then the angles by default unit is taken as radian. Did you get my point? So if it is in degrees, we'll have to specifically mention this degree as a unit over here. But if it is in radian, we either don't mention anything or put a C. So whenever you put this unit C or don't put anything on an angle, by default, its unit is taken as radian. That's a convention, a tradition we follow, a practice we follow, a method we have. So what is the point here? The point is pretty simple, students. I am trying to define 1 radian. I am trying to define 1 radian. What is 1 radian, students? I hope you do remember 1 radian can be developed with this whole scenario as what? Sir, angle subtended by an arc of what length? Sir, an arc of length equal to the radius of the circle. Equal to the radius of the circle. On the or at the center of the circle. At the center of the circle. So at the center of the circle, an arc subtending an angle. So the arc is having the length equal to the radius of the circle. So that angle which it is subtending will be of 1 radian. Did you all get this? Did you all understand this? Everything regarding mains or mathematics or everything, my friend, is available as a strategy if you just visit our video section. I'm constantly telling you. I'm here still focusing on one major concern, which is trigonometry. So I'll be more specifically dedicated towards trigo, identities, ratios, equations, functions, inequations of trigonometry. No, Surya, it's not length. It's length actually, but angular length. So in terms of inclination of a line with respect to other line, technically an angle, but angle has different units like grade, degrees, radians. Grade is obsolete, it is outdated. So we use 2 majorly, degrees or radians. So if you have degrees, you know degrees. If you have radians, you know now radians. Okay, sir. So can we really relate radians and degrees? Can we really relate degrees and radians? Of course, they both are angles. So why can we not? If I simply ask you this basic idea, if you could help me with this, let's say there is a circle and this circle has a center. So let's say there is a diameter over here. Let's say there is a diameter over here. I hope you can see that this is the diameter. So can you help me with this angle? Sir, this angle, if you are asking, this is clearly a diameter. So diameter at the center subtends an angle 180 degree. So this angle we clearly know is 180 degree. Okay, great, brilliant. So let's say the radius of this circle, is r. Yes, I am going to tell you all the identities of trigonometric ratios, functions, everything. So what do you think, students? What could be the length of this arc? Can you help me with the length of this arc? Sir, what about this arc? This is clearly a semicircle. So I know the circumference of a circle, perimeter of the circle, which is 2 pi r, but it is semicircle. So half of 2 pi r is, I hope you remember and realize, is pi r. So there in this case, length of this arc is pi r. Yes, my friend, all the identities which I have told or taught in Arjuna JEE in English and Laksh JEE in English, all those identities I will be teaching in this one short video. So if you want to revise all those identities in one video, through one video, here you have an opportunity. So coming back to the discussion, everyone, please pay attention here. So we have L, we have theta, we have R. So we know as per the definition, theta is L upon R. Theta is L upon R. So theta is L upon R. What is L? Sir, L is pi R and R is R. But sir, you told us that theta in degrees here in this case is 180 degree. Yes, I told you that. So theta in degrees here is 180 degree. So R and R are cancelled. So I will say that theta, which is in radians, is pi now because R and R are cancelled. So pi radian is equivalent to what? It is equivalent to 180 degrees. Did you all get something really beautiful and important? A very insightful result. What is that, sir? That relation simply tells you something really important and crucial now, that we have cracked that pi radian is 180 degree, which means if I ask you 2 pi, would you not say it will be double of 180 degree? If I ask you pi by 2, you would say half of 180 degree, which is 90 degree. If I ask you half of pi by 2, which is pi by 4, that will be half of 90 degree. If I ask you 1/3 of pi, 1/3 of pi, so you'll say 1/3 of 180 degree, which is 60 degree. If I ask you 1/6 of pi, which is 1/6 of 180 degree, which is 30 degree. So do you realize how are we converting angles which are given in radians into degrees? Are you all understanding this conversion comfortably? Okay, sir, we are getting it a little, but can you take some more examples? Yes. For example, what if I ask you, what do you think of 2 pi by 3? So 2 pi by 3 is in radians. Sir, can we convert this radian into degrees? How? We simply know one very basic and crucial idea here, that pi is 180 degree. What is pi? Pi is 180 degree. So if I substitute this pi by 180 degree, this is 2 into 180 degree divided by 3. 180 by 3 is 60. So 60 into 2 is clearly 120 degrees. So if somebody ever asks you, what is 2 pi by 3 in degrees? What will I say? I'll say 120 degrees. I hope it's simple now. Let's say, sir, opposite we want to do. What do you mean by opposite? Let's say we want to know radian of 150 degree. Can we work out a radian conversion of 150 degree? Yes, we can. Sir, how? You tell me one thing very clearly. What is 180 degree? Sir, 180 degree is pi radian. So what will be 1 degree? Sir, 1 degree will be pi by 180 radian. I have divided both the sides by 180. So 150 degree, don't you think, will be 150 into pi by 180. Unitary rule. You must have studied this in 5th or 6th standard probably. 5 chocolates cost you 10 rupees. 1 chocolate will cost you 2 rupees. So 3 chocolates will cost you 3 into 2, 6 rupees. That basic calculation I have performed. Don't you think so? So with this, what do we get? I hope you do realize this 0 are cancelled. 3 into 5 and 3 into 6. Correct me if I'm wrong. So this is 5 pi by 6. So first of all, tell me honestly, in the comments, everybody, did you realize that how are we converting radians into degrees and degrees into radians? Did you all understand this? All the participants, do let me know. Are you all comfortable with degree into radian and radians into degree conversion? Yes or no? Everybody. Did you all get this? All the participants. If you are comfortable with this, I will move ahead with the next part, where I'll just give you this part which we have already discussed, and then we'll talk about some really crucial and important ratios. And now we are entering into trigo. Angles we are done. Now let's talk about trigo. So trigonometric ratios now we are discussing. Something very beautiful we observed. Let's say I want to measure the height of a pyramid. I want to measure the height of a pyramid. This is a pyramid. Those pyramids in Giza. So if I want to measure this pyramid, duration, I think again same, around 9:30, 10 o'clock, I'll be done. So let's say I want to measure the height of this pyramid. So what they noticed is that if, you look at sun, its inclination, and the beauty here is that the height you want to measure, of course, this is the height here. So in a trigo, we developed this idea. That by using similarity, we can bring both of them on the same page, which means the bigger triangle, which is what we are using to measure the height of the pyramid, and the smaller triangle which we have created by taking as its similar. One very beautiful observation they made was that here, if they are similar, this angle will be same. So if these angles are same, we are already there, Habib Rahman. We are already continuing that. I think 3 to 4 chapters we have already done. Remaining chapters also will start very soon. And that's not a backlog series there. That's actually a series where we are covering all the chapters of class 12 standard. So there they noticed that, sir, you would be amazed by this, that here if I call this point as A, this as B, this as C, this as D, and this as E. So by similarity of triangles, we know something really beautiful. I hope you know that, sir, this angle is 90 degree, this angle is 90 degree, this angle is theta. So for the bigger triangle also, EAD angle is also theta. And similarly, this angle will be 90 minus theta. So this angle here also will be 90 minus theta. And this is clearly evident that both of the triangles are similar. Based on that, a conclusion was brought. Which conclusion? That if you take ratios, for example, perpendicular and base, in this triangle also perpendicular and base, so that ratio will be same for this bigger triangle or for a small triangle, because the angle is same for this right angle triangle. Not just that, so if you take the ratio of perpendicular and hypotenuse in this smaller triangle, and if the ratio of perpendicular and hypotenuse in this bigger triangle, that ratio will also be same because of this theta, which is same in both of the triangles. So if you take the ratio of base and hypotenuse in the smaller triangle, the ratio of base and hypotenuse in the bigger triangle, that will also be same because of this theta, which is same in both of the triangles, both of the right angle triangles. So they labeled these ratios, they named these ratios. So if I'm taking perpendicular and hypotenuse, if I'm taking base and hypotenuse, if I'm taking perpendicular and base, if I'm taking these respective ratios, we have started calling them names. What names did we give them? That's exactly what I am trying to discuss here. Let's say there is a triangle. There is a triangle. Please pay attention, everyone. And there, this is an angle A. This is an angle A. So with respect to this angle A, the side which is opposite to A is called perpendicular. The side which is adjacent to this A is called base. And this largest side over here, which is opposite to the 90-degree angle, is called hypotenuse. I am sure you all are aware of it already, aren't you? So we came up with three conclusions here that, sir, if you take a ratio of perpendicular and hypotenuse, it will be called sine ratio of that angle A. If you take ratio of base and hypotenuse, it will be called cosine ratio of that angle A. And sir, if you take the ratio of perpendicular and base, it will be called tangent ratio of A. Conventionally, we write it as sine A. This is cos A and this is tan A. But here, please understand, some of the students take it as a product of sine and A. No, it's not a product here. This is sine ratio of A. Sine is a function, a behavior of this angle A with respect to this angle A. So this is not a product. I hope you're getting my point, everybody. So I hope this is very well understood by you all. Now there they did one more thing, that they took their reciprocals. So reciprocal would mean the reciprocal of sine A is cosec A, cosecant A we call it. The reciprocal of cos A was secant A, sec A we call it, which is reciprocal of cos. And reciprocal of tan A is cot A, which is reciprocal of tan, so we call it cotangent as well. Everybody processing this? That's good, my friend. That's brilliant. Good, keep it up. That's brilliant. Very nice, very nice. Excellent. So keep participating, keep interacting. That's very good that you are learning. Now, if I could take you through some values, some really crucial and important values, which I'm sure you already are aware of, I think this is the table which is going to be something really important. And this you already know since your 10th standard days. And if you ever forget these values, I have this very simple trick or technique which you all must have already learnt, I believe so. So you have 0 degree, you have 30 degree, you have 45 degree, you have 60 degree, and you have 90 degree. And you want its sine ratio. So sine 0 degree, sine 30 degree, sine 45 degree, sine 60 degree, sine 90 degree you want. So begin with 0, 1, 2, 3, 4. Divide all of these values by 4. Divide all of these values by 4 and take their square root and take their square root and take their square root. So what happens when you do so is, I hope you do realize 0 by 4 is 0, its square root will be 0. 1 by 4 is 1 by 4, its square root will be 1 by 2. 2 by 4 when simplified is 1 by 2, its square root will be 1 by root 2. 3 by 4 is root 3 by 2 when you take its square root. 4 by 4 is 1, its square root is 1. Now, one thing very beautiful you'll all notice is this, that sine and cos in terms of angles are complementary. Sine and cos in terms of angles are complementary. Complementary means sine 30, cos 60 equal. Sine 60, cos 30 equal. Sine 0, cos 90 equal. Cos 0, sine 90 equal. Sine 45, cos 45 equal. Which means here, if you just reverse these values, cos 0 will be 1. Cos 30 degree will be root 3 by 2. Cos 45 degree will be 1 by root 2. Cos 60 degree will be 1 by 2. And cos 90 degree will be 0. I hope you all get that. You all are understanding it. Everybody, do let me know if there is any confusion. Now, one more thing very beautifully you all will notice is this, that if you want tan theta. So tan theta you all must have noticed by now that tan theta is clearly sine theta upon cos theta. I'm sure you know that. So sine upon cos, when you do 0 upon 1, that's 0. 2 and 2 are cancelled, so it is 1 by root 3. 1 by root 2, 1 by root 2, that's 1. 2 and 2 are cancelled, so it's root 3. And 1 upon 0 is clearly not defined. Yes or no? Everybody got this part? So this table I'll hope that you will remember. And you will paste it on the wall in front of your study table so that whenever you go through it, you revise it. By the way, in 10th standard already, you must have practiced a lot so that this table is already memorized by you. I believe so. I hope this assumption I can take here. So with this assumption, what if I ask you their reciprocals? For example, if I ask you cosec 45 degree, don't you say it will be root 2? What if I ask you sec 60 degree? Would you not say it is 2? What if I ask you cot 30 degree? You will say root 3. So I think that's simple and easy. You are able to crack it. Everybody, do let me know if there is any confusion. Yes or no? Now, one more very beautiful thing you can derive or deduce when you look at Pythagoras theorem. What is Pythagoras theorem? Sir, perpendicular square plus base square is hypotenuse square. Pythagoras has said it very beautifully. Good, Padmesh. That's brilliant. So if I divide both the sides by h square, it will be p by h whole square. This will be b by h whole square, and that will be h by h whole square, which is 1. Yes or no? So what is p by h? I hope you know. Sir, perpendicular upon hypotenuse, that is sine. What is b by h? Sir, base upon hypotenuse, that is cos. And 1 is 1. So don't you think that we have derived an identity? Sir, what do you mean by an identity? I am not saying it is an equation. Had it been an equation, it would have solutions. This is an identity because this is true for all the values of theta. Any value of theta you put here, it will be satisfied. Any value of theta you put 0 degree, 30 degree, 45 degree, 70 degree, 80 degree, 82.5 degree, 0.9 degree, whatever angle you put here, sine square of that angle plus cos square of that same angle will always result in 1. Are you understanding this? So this is an identity, not an equation. Are you learning this difference? By the way, this same discussion we had in the last class as well when we discussed quadratic equations, theory of equations as whole. Remember that? Along with this, you tell me, what if I divide both the sides by b square? What if I divide both the sides by p square? I think when you do that, you will get two more identities, which are these. 1 plus tan square theta is sec square theta. 1 plus cot square theta is cosec square theta, which in a more better manner or in a different manner can be written as sec square theta minus tan square theta as 1. And here cosec square theta minus cot square theta as 1. And there you know this, sine square theta plus cos square theta is 1, or cos square theta is 1 minus sine square theta, or sine square theta is 1 minus cos square theta. Everybody knows that, I believe so. Do let me know if there is any confusion. Please ask if there are any doubts, queries or concerns. Yes or no? Okay, sir, great. Let me just have some water. By the time you watch or look at this graph, everybody, this is the graph of sin x. Just give me 2 minutes. Here I'll say that, are you noticing some really good and important things? Sir, what are those things? What are those things? Pay attention, everyone. When you look at the graph of sine, sir, how do we draw this graph? They started noticing the angles and the values, and they connected the dots. And when they connected the dots, they got a graph. So that graph clearly looks like this. If you don't believe me, I'll show it to you, don't worry. Let's say if I give you the graph of sin x, right? So let me just show you the graph of sin x. This is how the graph of sin x look like. Everybody noticing this, everybody seeing this. So this is continuous. If you notice it on the x-axis, it is existing there from minus infinity to infinity. And one very beautiful fact you must notice is that, sir, on the y-axis, it is never going above 1 or below -1. What is your observation here? Don't you think, sir, observation is really simple? That for sin x, we notice that its graph exists from minus infinity to infinity. So in relations and functions, we have seen this concept of domain and range. So all the values this sin x can take as input, the argument, the values of x, are what? Any real value, sir. Which means it can take any value from minus infinity to infinity, so its domain will be real, R. But when you look at the graph of sin x, sir, it never goes above 1 or below -1. It never goes above 1 or below -1. So don't you think, sir, that here in that case, its range will be strictly -1 to 1, closed? Why? Because it is never below -1 nor above 1. Everybody processing this idea, let me know if there is any confusion. Everybody, yes or no? Okay, sir, we got this. But apart from that, don't you think or notice that this is a periodic function? Sir, what do you mean by periodic? Look at this curve, 0 to 2 pi. The same curvature you will see from 2 pi to 4 pi, 4 pi to 6 pi, minus 2 pi to 0, minus 4 pi to minus 2 pi. So this same chunk you will keep seeing again and again, time and again. So here, don't you think and notice and see that, sir, this is clearly a periodic function. This is clearly a periodic function. It repeats, it recurs, it shows the same pattern. So there we say it is a periodic function. And what do you mean by period? So period here means that 2 pi is that chunk which will be unique, and then the same chunk will keep getting repeated. Are you seeing the pattern here? One more, or rather 3 more very crucial and beautiful and important things you could develop here. That, don't you think that if I ask you that when do you see sin x to be 0? Graphs application in trigonometry. Padmesh, shall I show you this with the help of questions? Whenever I'm doing questions on trigonometric equations or two expressions which are equal, and what if I do that question with the help of graphs within seconds? I don't solve anything at all. I just draw two graphs, find their intersections, and get the question done. What if I show you in that manner very soon with the help of questions? So have patience. I'll demonstrate that. Don't worry. The applications of graphs in Trigo. So right now, do let me know in the comments, when do you see sin x to be 0? If I ever say that sin x is 0, what do you conclude about x? Sir, sin x is 0, right? Sin x is 0, at pi, at 2 pi, at 3 pi, 4 pi, 5 pi, minus 2 pi, minus 3 pi. So, sir, any multiple of pi, integral multiple of pi, if you take, sin will be 0. So, would I not say that sin x is 0 at n pi? Wherever x is n pi, sin x will be 0. By the way, what is n? Sir, here, n is an integer. Remember that, everyone, from set theory, for all belongs to this. Z is the set of integers. Remember that discussion, everybody, yes or no? So there, sir, if you talk about this result, can we talk about some more results? Yes. What if somebody says sin x is 1? What if somebody says sin x is 1? Same here, my friend. Happy to see you. Good to see you. And now keep up. What do you think of x? Okay, sir. Now we want to know that when do you see sin x to be 1? Yes. So sin x becomes 1 at pi by 2. Then at 3 pi by 2, no. Then at 5 pi by 2, yes. So sir, it became 1 at 1 into pi by 2. Then it became 1 at 5 into pi by 2. So 1 into pi by 2, 5 into pi by 2, 9 pi by 2. Are you realizing a pattern? Are you realizing a pattern? There is a pattern. Sir, what pattern? If you look at multiples of 4 and if you add 1 to them, you will get 1, 5, 9, etc. For example, I am saying that 4 into 0 plus 1 is 1. 4 into 1 plus 1 is 5. 4 into 2 plus 1 is 9. So, sir, if I put a pi by 2 here, which means if I say 4n plus 1 kind of multiples of pi by 2 if I take, then are you saying I'll get sin x to be 1? Yes. That's my point. That's my point, my friends. That's exactly my point is. My point is pi by 2, 5 pi by 2, 9 pi by 2, 13 pi by 2, 17 pi by 2. These are the multiples of pi by 2 where sin x is 1. And these are not some random multiples of pi by 2. They have a specific pattern. The pattern is they are 4n plus 1 kind of multiples of pi by 2. Multiples of 4 plus 1. 1 pi by 2, 5 pi by 2, 9 pi by 2, 13 pi by 2, 17 pi by 2, 21 pi by 2. Noticing what is happening here? Table of 4 plus 1. So based on that, if I ask you one more result, what do you think? When do you see sin x to be minus 1? Can you let that, can you write that part in comments? I'll be really happy and I'll get this notion or idea that you're understanding it. If somebody tells you that sin x is minus 1, what do you think of x? If you have understood this part, do let me know. When would you see sin x to be minus 1? If you are having an understanding of whatever we are doing here. Okay, sir. If we don't even remember it, we can develop it. By how? By seeing that, sir, first of all, at 3 pi by 2, I notice it is minus 1. Then at 5 pi by 2, no. Then again at 7 pi by 2, again at 7 pi by 2, it will be minus 1. So, sir, first of all, it happened at 3 pi by 2, then 7 pi by 2, then 11 pi by 2, 15 pi by 2, 19 pi by 2, 23 pi by 2, 27 pi by 2. Are you again not noticing a pattern? Sir, what pattern? Again, this is still an odd multiple of pi by 2. But to be more specific, not merely any odd multiple of pi by 2. This is 3, then 7, not 5, 7, then 9, not 7, then 13, not 11. So, sir, are they not the category of multiples which are 4n minus 1? Which are 4n minus 1. So whenever x is this category of multiple of pi by 2 which is 4n minus 1, you see sin x to be minus 1. Sir, what exactly did you say? Can you repeat? Yes, I will. Don't worry. If you did not get this, that's good, my friend. That's good. Yes, as we discussed in Arjuna. Beautiful. Excellent. Keep it up. So of course, as Amal, our friend, is saying, that instead of writing it as 4n plus 1, you can write it as 4n minus 3 as well, which is perfectly fine. And instead of writing it as 4n minus 1, you can write it as 4n plus 3 as well. It is totally up to us. Beautiful, good, keep it up. That's good, Padmesh, excellent. So I repeat, if pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, 13 pi by 2, they all are multiples of pi by 2. But sir, some multiples of pi by 2 are giving us 1. The remaining multiples of pi by 2 are giving us minus 1. And alternatively, it is happening. So technically, they all are odd multiples of pi by 2. So if they are odd multiples of pi by 2, they are either of this category 4n plus 1 or 4n minus 1. So at all these category of multiples of pi by 2, which are 4n plus 1, sin x will be 1. At these category of multiples of pi by 2, which are 4 and minus 1, sin x will be minus 1. Sir, why are we emphasizing so much on this basic learning? Do we really need to understand it, even if we find it a little complicated and tough to remember? Yes, you should. Sir, why? Because trigonometric equations will ask you. Sir, but I have heard it somewhere that trigonometric equations as a chapter is removed from the syllabus by NTA. I will in this very session only show you questions asked by JEE Mains based on trigonometric equations. So even if they claim that this chapter is removed from the syllabus, I will show you the questions. Not indirectly, not subtly, direct, straightforward questions based on trigonometric equations. And there you need this. When is sin x 0? When is sin x 1? When is sin x minus 1? That generalization you should be able to bring. Then only you will be able to write general results, particular solutions, specific solutions. All that comes with this understanding. Did you all get this? Whatever we have discussed regarding the graph of sin x, everyone comfortable with that? Just give me a quick thumbs up so that we can move towards the next graph, which is cos x. Cos x is technically nothing but the same sinusoidal wave, but you shift this graph pi by 2 units leftward along with the x-axis. Yes. So the only change which happens is that sine was going like this. So this time cos just shifts a little by technically pi by 2 units along with the x-axis on the left side. And that's where you see the graph of cos x getting formed. So sir, what are we noticing here? Again, don't you think that sir, graph of cos x also exists between minus infinity and infinity? Yes. So again, if I ask you the domain of cos x, that's R, which is minus infinity to infinity, which means here cos x can also take any real value as an input, as an argument. But when you talk about the output of cos x, again, don't you notice that sir, the graph is strictly either below 1 or above minus 1. It is clearly not below minus 1 nor above 1, which means the graph is revolving, rotating or roaming between minus 1 and 1 only, which means that's range of this function cos x is minus 1 to 1. Sir, is this also a periodic function? All the trigonometric functions are periodic. Sine, cos, tan, cos x, sec, cot, they all are periodic. So if you look at cos, something which you notice at 0, the same thing will be noticed by you again after 2 pi. So the curvature which we see from 0 to 2 pi, the same curvature repeats. The same curvature repeats. So this chunk which you are seeing from 0 to 2 pi, the same chunk keeps on getting repeated. So if you copy it, keep pasting it, keep pasting it, keep pasting it, you will see or get the graph of cos x. So what am I trying to tell you here is that cos x is up to an extent more like sine, but it shifts. And because of that shifting, again, if I talk about those 3 results, can you help me with those? Everybody, be quick now in telling me 3 results. When do you see cos x to be 0? When do you see cos x to be 1? And when do you see cos x to be minus 1? Do write this in the comments. I'll be really happy, glad and proud if you could tell me this. If you could tell me these 3 results or conclusions. Cos x is 0, 1 and minus 1. Yes, my friend, this session is enough if you want to revise it theoretically. The concepts, the identities, the formula if you want to learn, this is always sufficient. But you also know this, something which we covered in almost 10 to 12 sessions, I think more than that, is getting covered here in merely a 3 to 4 hour session. So something must be getting compromised. So if I'm ensuring that I'll cover the whole theory, mostly yes. So what is getting compromised? Your practice. So to get better at this chapter, to get better at this concept, you need more practice. So after this session, solve last 6 years JEE Mains PYQs. It will strengthen this chapter, this concept. You will consolidate it with practice. So do that practice by yourself. That is missing. That will not be doing here. I'll try to do some questions. Of course, some apt appropriate questions, but not many actually. I hope I have answered your query, my friend. So 3 questions I have asked and nobody has responded. That's very unfortunate. So I hope some of you may have already seen this happening, that sir, you asked cos x is 0. Yes. So cos x is 0 wherever the curve intersects the x-axis. So sir, if you look at the pattern, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, 13 pi by 2. So sir, you are saying any odd multiple of pi by 2? Yes. Not just 4n minus 1 or 4n plus 1, any odd multiple of pi by 2. Yes, you heard me right. Which means what? Which means whenever cos x is 0, x will be any odd multiple of pi by 2. Sir, odd can be written as 2n plus 1 as well. Yes, that's totally up to you. You can write it as 2n minus 1 or 2n plus 1. It is always odd as long as n is an integer. Got my point? Now quickly help me with these two results, students. When do you see cos x to be 1 and when do you see cos x to be minus 1? Quickly everyone, quickly. I hope you are seeing some pattern. That sir, if we notice cos x is 1 at 0 but minus 1 at pi, but again 1 at 2 pi, but minus 1 at 3 pi. So sir, we are noticing something really good. 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. These are the multiples of pi where cos x is 1. What are these? 0, 2, 4, 6, 8. What are they? So they are even multiples of pi. They are even multiples of pi. So would I not say that if somebody claims that cos x is 1, would you not say, sir, x will be even multiple of pi? X will be even multiple of pi. Now at least this one you can tell me, right? This one you can tell me, right? When do you see cos x to be minus 1, students? Can you quickly help me out with cos x being minus 1? Sir, you want cos x to be minus 1? Yes. So sir, we noticed it is minus 1 at pi. Then it will be minus 1 at 3 pi, then 5 pi, 7 pi, 9 pi, 11 pi, 13 pi, 15 pi, 17 pi, 19 pi. I hope these many examples are sufficient to tell you, sir, odd multiples of pi. Odd multiples of pi are the points where cos x will be minus 1. So will I not say that if cos x is minus 1, x will be an odd multiple of pi? Everybody got this? Any confusion so far? Any queries so far? Any doubts so far? Do let me know if there is any query. Please ask if there are any doubts. Let me help you with one more very beautiful graph and you tell me that what change you are noticing here with this graph and why are you noticing this change with this graph. This here is a graph of 10x. This here is a graph of 10x. Okay, sir. But sir, why is this graph like this? Why do we see this graph to be like this? Why are we seeing this graph to be like this? Why is this graph like this? Why are we seeing this graph like this? Can somebody answer this? This time the graph breaks. This time it is not a continuous function. This time this wave is not a continuous curve. This time the wave breaks. The graph breaks. Why is it happening? Can somebody tell me? Can somebody tell me why do we see the graph of 10x to be a discontinuous one which breaks? I hope all of you know that sir 10x is clearly sin x upon cos x. We know, sir, 10x as a function is clearly sin x upon cos x. So this is like a rational function. Absolutely, absolutely. So sir, if cos x becomes 0, I think 10x will not exist. It will not be defined. And when does cos x, when is cos x is 0? When do you see cos x to be 0? Sir, cos x is 0 at any odd multiple of pi by 2. So I am saying that here 10x could be defined for any real value of x. But sir, wait a second. Whenever you see odd multiple of pi by 2, it would not be defined. Why? It would not be defined. Why? Sir, because that odd multiples of pi by 2 will make cos x to be 0. Sine upon something 0 is not defined, and that's where 10x will be not defined. Did you all get this statement, or shall I repeat it? All the participants. What did I just say? I said that 10x will be defined for all x, except for those x where cos x is 0, because there 10x is not defined because cos x is 0. Where is cos x not defined, sir? Where is cos x 0? Sir, cos x is 0 at all the odd multiples of pi by 2. Getting it, everyone? So, sir, if I try to draw the graph, how will it look like? Okay, let's try and draw the graph of 10x. Everybody, please pay attention. This, let's say, is the x-axis. This here is the x-axis, and that's your y-axis. Please pay attention, everyone. That's your y-axis. Now, I am drawing some line parallel to the y-axis. Let's say this is one of those lines which is parallel to the y-axis. Some more I draw. Some more I draw. Some more I draw on the negative side of y-axis as well, x-axis as well. Like this, and like this. And now I locate all of these points as multiples of pi by 2. Sir, what do you mean by that? For example, here, let's say this is origin, intersection of x-axis and y-axis. So this point here will be pi by 2. This will be pi. This will be 3 pi by 2. This will be 2 pi, and so on. Similarly, this point here will be minus pi by 2. This will be minus pi. This will be minus 3 pi by 2. This will be minus 2 pi. Okay. Okay. Now what? Now, when you look at the graph of 10x, so sir, 10x graph between 0 to pi by 2 goes like this, and between minus pi by 2 to 0 stays like this. But it never reaches pi by 2 because at pi by 2, it is not defined. Are you understanding my language, everyone? So the same chunk which we have just drawn, repeats. Which means, again, between pi to 3 pi by 2, it will be like this. Between pi by 2 to pi, it will be like this. Same, between 3 pi by 2 to 2 pi, it will be like this. 2 pi to 5 pi by 2, it will be like that. Same thing will happen here. Minus pi to minus pi by 2, it will be like this. Minus 3 pi by 2 minus pi, it will be like this. Minus 2 pi to minus 3 pi by 2, it will be like this, and so on. So again, do you all not agree that this is again a periodic function? It is. Rather, I have already said in the beginning only that all of these functions, sine, cos, tan, cos x, sec, cot, they all are periodic. But sir, does the story end here? No. Wait a second. Something really important I'm willing to tell you here. That can you help me about its domain? Sir, you have already written the domain, don't you realize it? This particular part here, where you said that x can be any real number except for odd multiples of pi by 2, was its domain only. Okay, sir. So if we have discussed its domain, what do you think of its range? Range means the existence of the graph along with the y-axis. So, sir, we see it is there from minus infinity to infinity without stopping, which means if I ask you the range, which means 10x. So, 10x lies between minus infinity to infinity, which means all the real numbers. Everybody getting it? Okay, sir. One more question I want to ask. Is it a periodic function? Yes, sir, it is. But what about its period? Sir, this time, this chunk which you see from 0 to pi, same chunk is from pi to 2 pi, 2 pi to 3 pi, and so on. So, again a periodic function with period not 2 pi, pi. For sine and cos, the period was 2 pi. For tan, the period becomes pi. Everybody realized it. Everybody understood it. Any queries or confusions if you have, please ask. One more question I have. Sir, what? When do we claim that 10x will be 0? When do we claim that 10x will be 0? Sir, come on. What a silly question you're asking. You want 10x to be 0. What is 10x, my friends? Sir, 10x is sin x upon cos x. So, sir, should you not say wherever or whenever sin x is 0, 10x will be 0? Did you get my statement, everyone? Whenever you see the numerator to be 0, the whole result will be 0. So whenever sin x is 0, 10x is 0. Now, can you answer this question in the comments very quickly? When is sin x 0? Sir, I think we have studied it very properly. Sin x, if you notice, is 0 at any multiple of pi. 0, pi, 2 pi, 4 pi. So, sir, if you are asking us, where is 10x to be 0? I'll say, whenever sin x is 0. Where is sin x 0? Sir, at all the multiples of pi. So, this is my answer here. This is my answer here. Yes or no, everybody? Did you all get this? Did you all understand this? Or shall I re-explain this? Everybody, give me a quick response. Based on that, can we now not draw cot x? Sir, cot x is 1 upon 10x. Cot x is 1 upon 10x. Can I say in a different language, cot x is cos x upon sin x? So this time, cot x will be not defined whenever sin x is 0. Don't you think so? And we have just discussed the points where sin x is 0. Sir, sin x is 0 at all the multiples of pi. So cot x is defined for all the real values of x except for all the multiples of pi. This is not wiggle sign, it is minus. This is minus. Everybody got this, yes or no? Okay, sir, we got it. I repeat, if 10x is from minus infinity to plus infinity, its reciprocal cot x will also be from minus infinity to plus infinity. Don't you think so? Don't you think so? Of course, sir. Of course, it will be. So when you talk about the range, don't you think it will be from minus infinity to infinity? Is it also a periodic function, students? Is it also a periodic function? Please tell me. Is it again a periodic function? It is indeed, sir. Don't you think so? That here also this exists from 0 to pi. And whatever curvature we see, the same curvature 0 to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi, and so on. So here, again, this is a periodic function, isn't it? Absolutely, absolutely. Yes, keep it up. That's nice. Very good, students. So it is again a periodic function with a period pi. My next question. Final question from cot. Can you answer this? When do you see cot x to be 0? Sir, you are asking cot x to be 0? Sir, cot x is cos upon sine. So wherever cos is 0, cot will be 0. When is cot 0? At any odd multiple of pi by 2. Remember that we had a discussion on cos. Remember we had a discussion on cos. Any multiple, any odd multiple of pi by 2 will make cos to be 0. So if I ever ask you cot x to be 0, what is your answer? What is your response? Sir, cot x is 0 at any odd multiple of pi by 2. Yes or no? Set of integers is either denoted by z or capital I. That's good, Amal. That's good, Amal. That's brilliant. Keep it up. Very nice. Very good. Everybody understood cot. Any confusions here? Any queries here? Any concerns here? If there are, please ask. I'll re-explain. Now let us draw the graph of sec x. Let us draw the graph of sec x. Everyone, pay attention. I personally, I know that, my friend, you're a dropper. Keep it up. We really appreciate it. I personally remember it with this method that I first of all draw the graph of cos. How? Sir, if you remember, the graph of cos goes like this. From minus pi by 2 to pi by 2, it goes like this. From pi by 2, 3 pi by 2, it goes like this. From 3 pi by 2 to 5 pi by 2, it goes like this, and so on. So this pink curve between minus 1 and 1, this is our graph of cos x. This is our graph of cos x. Are you noticing this is our graph of cos x? Now, if you look at these curves, for example, look at this curve. Look at this curve. If you simply invert this bucket, you look at this curve, if you look at this curve, if you simply invert this bucket, if you turn it upside down, if you look at this curve between 3 pi by 2 to 5 pi by 2, if you again invert it, if you turn it upside down, don't you think, don't you see something really amazing, good, beautiful, and nice will happen? This is my way of remembering to draw the graph of sec x. Okay, sir, what are you saying actually? I am saying few things which are very straightforward. First of all, how do we see sec? Sir, sec is reciprocal of cos. So 1 upon cos x is sec x. So, sir, cos was having a domain from minus infinity to infinity, which means cos was defined everywhere. Will the same be true for sec? Because, sir, whenever cos is 0, cot was not defined, so sec will also not be defined, because whenever cos is 0, 1 upon cos, that is sec, will be not defined. Cos is 0 at all the odd multiples of pi by 2. Absolutely. So odd multiples of pi by 2 means what? Minus pi by 2, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, 13 pi by 2. There, sec x will be not defined. Yes. Good, keep it up. Really nice. So these lines which are parallel to the y-axis passing through minus pi by 2, pi by 2, 3 pi by 2 from x-axis will be behaving as asymptotes. The tangents to this curve which meet to the curve at infinity, they never meet. The curve just keep approaching, but it never reaches. Understanding my language, everyone? Is there any confusion? Please ask. Are there any doubts? Please ask. Everybody getting this idea? But sir, few things are still here, same. Of course, cos was from minus 1 to 1. So sec is its reciprocal. I hope you do remember one very insightful and interesting fact about the reciprocal function. I will demonstrate it here as well. Don't worry. I'll show you the reciprocal function so that you get it more clearly. Let's say if I draw the curve y is equal to 1 divided by x. This is your reciprocal function. Undo, do we have undo? Do we have undo? Yes, we do have undo. So this is a reciprocal function. Are you noticing this? Are you seeing this graph, everybody? Are you seeing this amazing and beautiful graph over here? Sir, why are we seeing this? Okay, let me just bring it on my page so that I can show you something really beautiful here. This here is the graph of y is equals to 1 by x. This here is the graph of y is equals to 1 by x. So this is minus infinity, this is 0, and this is going till infinity here. I hope you do notice that this point over here is minus 1, comma minus 1. This point over here is 1, comma 1. So what I'm saying here is, just give me a moment, everyone. You guys continue with your chatting and all. I just don't want to see something irrelevant. So I'm just keeping it removed so that I stay focused. So here what am I saying is that when you see or say that cos x is from minus 1 to 1, when you say cos x is from minus 1 to 1, so I avoided keeping cos x as 0 because now I am interested in sec x, which is 1 upon cos x. So when cos is from minus 1 to 0, when cos is from minus 1 to 0, you see, sec is from minus infinity to minus 1. Does it make some sense, everyone? Similarly, when cos is from 0 to 1, you see, sec is from 1 to infinity. Do you all notice it? Everybody, give me a quick response. That's my whole point. That's my whole point. My point is pretty simple here, that if you see or notice that cos is from -1 to 1, sec will be either -infinity to -1 or 1 to infinity, because it is the reciprocal here. So with this, yes, wherever cos was 1, sec will be 1. Wherever cos was -1, sec will be -1. 1 upon 1, 1 upon -1. But sir, apart from that, sec will be either greater than 1 or less than -1. So don't you notice or see that, of course, sir, in terms of domain, I will say that whenever cos is 0, sec will be not defined. Technically, odd multiples of pi by 2, I would avoid taking. But when you talk about the range of this function, don't you say or think that a range here will be any value either less than -1 or greater than 1, where 1 and -1 are included. Is it a periodic? Indeed. Period 2 pi, same as cos. Shall I ask you again those same 3 results? Sir, when is sec 0? Never. Because it is either greater than 1 or less than -1. But sir, when is sec 1 and -1? Same, wherever cos is 1 and -1 respectively. So at even multiples of pi, 0, 2 pi, 4 pi, 6 pi, 8 pi, sec will be 1. At odd multiples of pi, 1 pi, 3 pi, 5 pi, 7 pi, that is 2 and -1 times pi, sec will be -1. Same as cos. Are you realizing why? Everybody, yes or no? With this, the final graph, and then we'll be done and we'll discuss the next concept, which is quadrant theory, to figure out any value, any angle. Yes, we'll move towards that. So cosec, I think, is same as sine if you notice something which we have noticed in cos and sec. How I personally remember it is in this manner, that if you notice the graph of sine, sir, graph of sine goes from 0 to pi like this, then pi to 2 pi like this, and minus pi to 0 like this. So minus pi to 0 like this, then 0 to pi, the graph of sine goes like this, then pi to 2 pi, graph of sine goes like this. So if I again invert this bucket, for example, between minus pi to 0, sine is like this. If I just turn it upside down, I'll get cosec x. Between 0 to pi, graph of sine looks like this. So if I turn it upside down, it looks like this, which is cosec. Between pi to 2 pi, sin x is this. So if I turn it upside down, it is cosec x. Isn't it again something straightforward and direct? How is cosec discontinuous while sin is continuous? A very beautiful question you have asked. Yes, my friend Vaishnav, but as I have already told you in the beginning, I can do either in one shot, but we cannot have both up to a large extent, which we have covered in 12 to 15 sessions of our Arjuna batch. Every session is of 1.5 hours. Can you imagine 15 sessions of 1.5 hours? That took us to complete this whole chapter. More than 15 sessions, to be very honest. And that we are covering or trying to cover in almost 3 or 4 hours. So it's really challenging if I make you do a lot of questions as well, practice in sense of practice. So theoretically, conceptually, fundamentally, I'll teach you everything from Trigo. But as I have been saying this since beginning only, you need to practice questions. Although I'll also be getting a lot of questions done, but let me teach you the basics first. Because in Trigo, you see a merger of a lot of concepts together. If I talk about mains or advanced previous year's questions, my friend, the latest one which you are asking for. So my hands are restricted a little. Let me teach few concepts. Then we'll definitely see questions, because questions are merger of multiple concepts together. So I won't be able to explain something if you don't have the concepts with you. So let me teach the concept first. Have I answered your query, my friend Vaishnav? Along with this, something very crucial and important I want to answer. Yes, cosec is discontinuous the way sec was discontinuous. Why? Because what is cosec? Cosec is clearly 1 upon sine. So does it not mean that whenever sine is 0, cos will be not defined? Absolutely true, sir. Absolutely true. Absolutely true. Absolutely true. I hope you do realize sin x is 0. Sin x is 0. Sin x is 0 at any multiple of pi. So 0 pi, 2 pi, 3 pi, 4 pi, 7 pi, 8 pi, all those multiples of pi will be the points where Amal, my friend, cosec will get discontinued. The graph breaks. Are you noticing? Yes or no? Yes or no? Good evening, everyone. I hope you all can hear me, see me clearly. So I hope I have answered your query, everyone. Comfortable? Same logic. Wherever sin x is 1, cosec x will be 1. Wherever sin x is minus 1, cosec x will be minus 1. So that we need not discuss. And the same result, students, range also is going to be either less than minus 1 or greater than 1. Sir, why? Because sine was clearly between minus 1 to 1. So its reciprocal will be either less than minus 1 or greater than 1. Everybody got this? Everybody understood it? Is it again a periodic function? Yes, with period 2 pi. Now we'll talk about this quadrant theory after a 10 to 15 minutes break. So you take a break, hydrate yourself, walk around, stretch, eat something if you want, and then we'll meet after 15 minutes. So take a 15 minutes break and then we'll resume. All right, everyone. So let's meet after 15 minutes. Here is a break of 15 minutes. We are continuing trigonometric functions, identities, equations, whether you are working on preparing for examination point of full chapter trigonometric functions, equations. With this one chapter, the language of either each chapter. One is absolutely important. Students, what do you think is going on here? We are continuing trigonometric functions, identities, and equations, and everything in this one shot. So whether you are watching. So if you all can hear my voice, if you all can see me, if I'm clearly visible and audible, students, do give me a quick response so that we can straight away again get started. I am reading some comments. Some people are asking, is this a one-shot series? This is a backlog series. A backlog series for all our, yes, the break is over. Come back everyone. If you all can hear my voice, if you all can, some comments, some people are asking, is this a one-shot series? This is a backlog series. Okay, so I hope I'm clearly visible and audible. Everybody give me a quick response. The break is over. Yes, the break is over. The break is over. If you all can hear my voice, can see me, can see the stream running. If my voice can reach you wherever your laptop, desktop or mobile phone is kept, come back. I hope you must have hydrated yourself, had a decent break, had something, ate something and stretched, walked around and now sit and again focus. We are going to continue with another amazing concept which is called quadrant theory. Somebody in the comment is asking, guys, is this a one-shot series? This is a one-shot backlog series. So backlog series means whatever chapters which are created as backlog in the Arjuna JEE English batch. Arjuna JEE English is a batch for class 11th JEE aspirants. So those who have joined us late, they may have missed some of these chapters like sets, relations and functions, quadratic equations, trigonometric functions, and quick response. I hope the stream is running smoothly and properly and I'm clearly visible and audible. I hope there is no problem. You all can hear me. Everybody give me a quick response. Can you all hear me? Can you all see me? Everybody? Just write in the comments if I'm clearly visible and audible. Because I see that there is some lag, there is some fluctuation with the network. So am I clearly audible and visible? Sir, I have solved. That's brilliant, Shashank. That's brilliant. Amazing. Keep it up. What if cos is in left x-axis? What will be its sign? Left x-axis. We'll talk about that. Don't worry. So I hope now I'm clearly visible and audible. I think the screen froze for a while. I think meanwhile, few seconds back. So I think it's working very, 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 very well now. Everybody. Now, quadrant theory, if I could discuss or begin. Some of you, or rather most of you, must have studied this concept in physics already as well. So this thing, I will make you revise. Yes. Yes. Everybody. Okay, so now I am sure everything is clearly visible and audible, running smoothly, the stream. Can you all hear me and see me? Sure, everyone. So here if I continue with this quadrant theory, first quadrant, second quadrant, third quadrant, fourth quadrant. So in first quadrant, all the ratios, sine, cos 10, cosec, sec, cot, they all are positive. So what do you mean by first quadrant? So here the angle is 0 degree or 0 radian. Then this is 90 degree or pi by 2 because you are moving in the anti-clockwise direction. Then one more 90 degrees rotation if you take, so this angle will be pi. One more 90 degree anti-clockwise rotation if you take, this will be 3 pi by 2. Again, when you rotate it by 90 degree, it will be 2 pi. Then again, if you take, it will be 5 pi by 2. Then again, if you take, it will be 3 pi. Then again, if you take, it will be 7 pi by 2. Then again, if you take, it will be 4 pi and so on. So ultimately, what do I notice? I clearly notice something really relevant and significant. That's that positive x-axis will always have even multiples of pi. What I clearly notice that negative x-axis will always have odd multiples of pi. Positive y-axis will always have 4n plus 1 category of multiples of pi by 2. Negative y-axis will always have 4n minus 1 category of multiples of pi by 2. Do let me know if this part is very well understood by everyone. All of these quadrants and specifically positive x-axis, positive y-axis, negative x-axis, negative y-axis. Yes or no? Everybody. Yes or no? Yes or no? Yes, my friend, regarding marks, weightage and everything, we'll do a complete strategy video. So if you visit our videos section, we'll definitely release a video. Don't worry about that. Advanced questions also will bring, don't worry, very soon. But let us get done these parts which are really important and crucial for our students who have joined us in Laksh and Arjuna batch for their backlog coverage. So here, if I could tell you something really important. Now, please pay attention, everyone. Whenever you are willing to take ratios, let's say I want to talk about sine 90 minus theta. So there we take this assumption that theta is something between 0 to pi by 2. Even if it is not, it is perfectly fine. So where is 90? Sir, this is 90 degree. This is pi by 2. So plus theta if I do, so I move in the anti-clockwise direction. Remember the very first thing in this session I told you, positive is anti-clockwise, negative is clockwise. So 90 minus theta when I do, I am placed in which quadrant? Sir, I am placed in first quadrant. So I hope you do realize whenever I say 90 degree minus theta, so this is 90 degree, minus theta will push me here. So this is my angle. But remember, whenever 90, that means you move from y-axis, either left or right, the ratios change. The ratios change means sine gets changed into cos, cos gets changed into sine, tan gets changed into cot, cot gets converted into tan, sec gets converted into cosec, cosec gets converted into sec if I'm moving from the y-axis. So this 90 degree is my positive y-axis. From it, I have moved theta degree. So I am clearly in the first quadrant. So if I'm moving from the y-axis, the ratios change. So sine will become cos. But sir, what about the sine, plus or minus? Sine is really simple scheme here, students. In the first quadrant, all ratios are positive. So if all ratios are positive, sine will also be positive. So I'll put a plus sign over here. Everybody got this? Let me take some more simple and direct and straightforward examples. Let's say I talk about 10 pi minus theta. So 10 pi minus theta. Can you locate pi? Sir, pi will be found here. Pi will be found here. Pi minus theta when you do, you are shifted or placed in the second quadrant. Pi minus theta. I hope you see this. And sir, in the second quadrant, sine and cosec are positive. All sine cosec, tan cot, cosec. Remember that, everyone. So in the second quadrant, sine and cosec are positive. So tan will be negative. So first of all, sine will be negative. Signature will be negative. Yes or no? Yes or no? Yes or no? Yes, I'm going to, but let me teach the theory first. Trigo's basics we are doing. 11th standard you are. I understand. This is a backlog series for our Arjuna batch students, my friend. So if I talk about the second quadrant part, please pay attention, everyone. In the second quadrant, tan is clearly negative because sine is positive. So I'm putting a negative sign. But sir, here we do clearly notice that, sir, tan is coming from pi minus theta. So pi is on the x-axis. So from x-axis, if I move either upward or downward, the ratios don't change. If I'm moving from the x-axis, the ratios don't change. So if the ratios don't change, tan will remain tan and it will be tan theta. Did you all get this part? Yes or no? Everybody. Thank you so much. Continuing further, let me take some more examples. Let's say if I talk about cos, please pay attention, everyone, 3 pi by 2 plus theta. Now, first of all, locate where is 3 pi by 2. So, sir, 0, pi by 2, pi. This angle over here is 3 pi by 2. And 3 pi by 2 plus theta. So, plus theta means anti-clockwise. So, where am I placed? I am placed in which quadrant? Fourth quadrant. I hope everybody is getting it. So, in fourth quadrant, what happens here is, please pay attention, everyone. Sir, sine, cos, sorry, all are positive. Sine, cosec, tan, cot, cos and sec. So in fourth quadrant, cos and sec are positive. So signature wise, it will be positive. But sir, look at this 3 pi by 2. This is y-axis. So from y-axis, if I move leftward or rightward, the ratio changes. From y-axis, ratios change. From x-axis, ratios don't change. So I'm moving from the y-axis, either left or right. So ratios would change. So cos will get converted into sine. So this will be sine theta. Vaishnav is asking, sir, why does the sign of the 10 become positive in the third quadrant even though both sine and cos are negative? So 10 is sine upon cos. So if both sine and cos are negative, negative upon negative is positive. And we are bringing all of these conclusions based on the graphs. So if you look at the graph of 10, whenever the angle is in the third quadrant, you will see the graph of 10 is above the x-axis, which means it is positive. So 10 in the first and third, positive. second and fourth negative. Sine in first and second positive, in third and fourth negative. Cos in fourth and first positive, second and third negative. Can you be more specific, Amal? What exactly are you saying? What exactly are you saying? I hope you got this part. This is something really straightforward, direct. If there is any confusion, please ask. Shashank, let me tell you my intent. If you're watching it from the beginning, the idea is really simple. This is a backlog series for class 11th students of our Arjuna batch. So we are making them revise the whole chapter, trigonometric ratios, identities, inequations, equations, functions, formula and everything from scratch. So if you want a good session, a dedicated session on practice, a complete practice oriented sessions where we are bringing JEE mains and advanced level problems, very soon all the 11th class chapters will also be started by us, and there I'll be taking more practice oriented sessions. As I've already told you in the beginning, this is more conceptual session where I'm clarifying all the concepts. Got my point, Shashank, my friend? Here I come with the next part. So I hope it makes complete sense now that whenever I move from the x-axis, whether upward or downward, the ratios don't change. But if I move from the y-axis, whether leftward or rightward, from positive y-axis or negative y-axis, the ratios do change. So two things. From where are you shifting? Are you moving from y-axis or are you moving from x-axis? Depending on that, you will decide change in ratio. Second thing, you got to decide in which quadrant you are. Even if the theta is greater than pi by 2, less than pi by 2, or anything less than 0, greater than pi by 2, then also, Amal, we follow the same process. Yes, fortunately, yes. And it gives you the same results, the good results. Trust me. So here I come back that quadrants also you need to take care of, because with the help of quadrants, we decided more clearly that whether this value will be positive or negative. Sir, how come are you giving this generalization based on this quadrant theory? Because we have seen the graphs. The graphs, when you notice and observe, you will start seeing this pattern which I'm generalizing with the quadrant theory. So if you just remember this method, you will be done. Let me take some very quick examples. You tell me in the comments what these values could be. For example, if I say cos 3 pi plus theta, what do you think the answer will be? What if I say sine 7 pi by 2 minus theta? What if I say 10 8 pi minus theta? What do you think the value will be? What if I say sec 9 pi by 2 plus theta? What do you think the value will be? What if I say cosec pi minus theta, the value will be? What do you think these values would be? Quickly, be quick, everyone. Quickly, tell me, what do you think the answer will be, everyone? So 5 questions I have asked you. Very quickly, we'll get all of these values. Let me begin with the first one. Cos 3 pi plus theta. Can you help me in locating 3 pi? Sir, we do know that any odd multiple of pi you will find here. But 3 pi plus theta will push you in the third quadrant. In the third quadrant, sir, cos is negative because tan and cot are positive. So first of all, negative. But if you are moving from x-axis, the ratios don't change. So 3 pi would not change the ratio. So it will be minus cos theta. I'm sure everybody has gotten this. We definitely will, my friend. We definitely will. So here, 7 pi by 2. Let's talk about the next result, everyone. We are now talking about sine 7 pi by 2. Where is 7 pi by 2? Sir, pi by 2. 3 pi by 2, 5 pi by 2, 7 pi by 2. So, sir, you will find 7 pi by 2 here. But 7 pi by 2 minus theta. So, again, in which quadrant you are? In the third quadrant. In the third quadrant, sine is negative because tan and cot are positive. So, this will be first of all negative. But, sir, 7 pi by 2, you are moving from the y-axis. So, if I move from the y-axis, the ratios change. So, sine gets converted into cos. So, it will be cos theta. Everybody got the same result? Yes or no? Yes or no? Yes or no? Everybody. Thank you so much, my friends. Pay attention, everyone. Pay attention, everyone. Yes, in this chapter only, we'll do trigonometric ratios. We are already doing. Then I'll gradually move towards identities. And then gradually we'll do equations as well. I'll get everything done. Don't worry about that. Now the next part. 10, 8 pi minus theta. Can you help me with 8 pi? Sir, we know even multiples of pi we get here. So this will be 8 pi. Minus theta will push me in which quadrant? Fourth quadrant, sir. Fourth quadrant. So 10, because of fourth quadrant, cos and sec are positive. So 10 will be negative. Yes or no? Unique soul, thank you so much, by the way. But here, sir, it is 8 pi. x-axis. So if we move from the x-axis, the ratios don't change. So 10 will remain 10. So it will be 10 theta. I hope the same result is gotten by you. Sir, what about 9 pi by 2? Again, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 4n plus 1. Multiples of pi by 2 we find on the positive y-axis. Plus 9 pi by 2 plus theta. So sir, you are shifted in the second quadrant. So sir, in the second quadrant, sine and cosec are positive, sec will be negative. But sir, do you notice that you are shifting from the y-axis? So if you are shifting from the y-axis, ratios change. So sec will get changed into what? Cosec. I hope you do know that, everybody, yes or no? Now the final one. Can you help me with cosec pi minus theta? Sir, pi you would find here, odd multiples of pi, negative x-axis. Minus theta will push us in the second quadrant. In second quadrant, sine and cosec are positive, which means cosec will be positive. So signature wise, it will be positive. But can you help me whether it will be cosec or sec? Sir, you are moving from the x-axis. So if you move from the x-axis, ratios don't change. So it will remain cosec theta only. These are all our 5 values. I think now quadrant theory is very well, completely, totally and absolutely understood by everyone. And here comes a question which most of you were asking for. Let's see how many of you are able to do it. So the moment you get the answer A, B, C, D, you need to write in the chat box. I'm starting the poll and let's see how many of you get it right. Everybody, do give it a try. So what is this question saying? The question is a pretty simple one. It simply says something really straightforward and direct. Sin x is minus 3 by 5. Where x is pi to 3 pi by 2, then they ask you a value 80 times tan square x minus cos x. Okay, sir. Let us talk about this angle, pi to 3 pi by 2. Sir, this is pi and this is 3 pi by 2. So the angle clearly lies in the third quadrant. This x is in the third quadrant. And in the third quadrant, we know that tan and cot are positive, which means sine, cosec, sec, cos will be negative. Yes. So if I know sin x magnitude wise is 3 by 5. So if I, let's say for a while say that x is this, so sine will be 3 by 5. So Pythagorean triplet says 3, 4, 5. Did you all get this? I'm talking about magnitude wise. I'm not talking in terms of signature here. So what if I bring two very crucial discussions in picture? What do you think of tan x? So tan x is perpendicular upon base. That will be 3 by 4. Will it be positive or negative? Sir, x is in the third quadrant. X is in the third quadrant. Tan is positive. So this will be plus 3 pi by 4. So magnitude wise 3 by 4. Signature wise also plus 3 by 4. Absolutely, this is easy, isn't it? Excellent. Now, sir, we need cos as well. Cos will be base upon hypotenuse. So magnitude wise 4 by 5. But sir, x is in the third quadrant. Cos is negative there. So signature wise, it will be minus 3 by 5. Yes. And with that, I'm sure most of you have gotten the answer. 80 times tan square x. What is tan square x? 3 square by 4 square, which is 9 by 16 minus cos square x. So cos x it is. So it is 4 by 5. Correct me if I'm wrong, because minus of minus is plus. So it is 4 by 5. Everybody got this? Sir, 16 into 5 is also 80. So 5 into 9, that I think is 45. 4 into 16, that I think is 64. Correct me if I'm wrong. Because 16 into 5 is 80, 80 gets cancelled by 80, so 9 into 5, 45, 16 into 4 is 64, that's your answer. So I think answer should be 109, correct me if I'm wrong. Option B, that's brilliant students, keep it up. A lot of you have responded. Good, Shashank, that's good everybody. Yes or no? Yes or no, everybody. I hope there is no confusion so far. Everybody listening and understanding comfortably. Yes or no? Yes or no? So with this, what is the correct answer here, students? Clearly, none other than option B. Good, everyone. I'm glad everybody must have gotten it. Some people may have forgotten writing it, but I'm sure you all must have gotten it. Now comes something really important and crucial. In 11th standard, at the initial stage, I have still seen some people doing this, which I'm sure not you guys do it, that when you say sine 30 degree plus let's say 40 degree, they do it like this. They say sine gets multiplied to 30 and they say sine gets multiplied to 40. I hope this is absolutely wrong. This is clearly a bad practice. You don't follow this. I am constantly, since the beginning of this lecture, telling you this is not a product here. This is not a product here. This is sine ratio of an angle. So when you begin with this data, when you say that sine A plus B you're saying, so sine A plus B is not sine A plus sine B, that's false. So sine A plus B, it has a valid proof as well, which I'm skipping, I'm just giving you the results. So this session now, if you receive this PDF after the session, this session, its PDF will work as a Bible for you to have all the trigonometric identities. Yes, do listen to me very carefully. I will make you revise all the trigonometric identities, all the identities and formulae from Trigo in this one session only. So can you imagine when you receive the PDF after the session through our WhatsApp channel, the link is given in the description, you will get the whole PDF of all the theories, all the formulae, all the identities of entire trigonometry. And if you avail it, isn't it going to be amazing? You can keep it as a Bible of Trigo. You revise it wherever you want, whenever you want. All the identities, I assure you, for ITJEE, you have my promise. So, everybody, focus. There I have sine A plus B, which is going to be sine A cos B plus cos A sine B. For example, if someday I ask you to figure out sine 75 degree, so you may find it by, can somebody tell me in the comments what is sine 75 degree? Sine 45 plus 30 degree. So it is not sine 45 plus sine 30 degree, that's false. So I'll say it is sine A cos B plus cos A sine B. Everybody listening and understanding? So sir, what are these values? I think you got the values. Sine 45 is 1 by root 2. Cos 30 degree is root 3 by 2. Then cos 45 is 1 by root 2. Sine 30 is 1 by 2. So 2 root 2 is the LCM. So our answer will be root 3 plus 1 whole divided by 2 root 2. That's what? Nothing but sine 75 degree. So I've given you a value. Will you keep it to yourself? Sine 75 degree. Similarly, if I'm asking you what will be the value of sine A minus B, then you say it is sine A cos B minus cos A sine B. Everybody got this without getting confused? Similarly, there is one more very crucial result, students. Just give me a moment, everybody. There is one more result which is called cos A plus B. Sir, what is cos A plus B? That is given by cos A cos B minus sin A sin B. What does it mean? Let's talk about that result as well. Pay attention, everyone. Pay attention, everyone. Here we are. Let's say if I ask you cos 15 degree, if I ever ask you the value of, let's say, cos 75 degree one more time. Let's talk about cos 15 degree this time, let's say. So here, don't you think that if I talk about cos A minus B, the identity will become cos A cos B plus sin A sin B. That's one more identity added to your list. So cos and sin are complementary in terms of angles. So whatever sin theta is, that same cos 90 minus theta will be. So we have cracked sin 75 degree. Do you remember that? Sir, it was root 3 plus 1 by 2 root 2. So sir, the same value will be cos 15 degree. Yes or no? What if I ask you to figure out cos 75 degree? Don't you think, sir, it will be cos again 45 plus 30 degree? Can we a little be quick here? So it will be cos A cos B, cos 45 cos 30. Cos 45 is 1 by root 2, cos 30 is root 3 by 2, minus sin A sin B, sin 45 sin 30. Sin 45 is 1 by root 2, sin 30 is 1 by 2. So this value we attain as root 3 minus 1 by 2 root 2. And don't you think, no, it's not at this stage, since it is the one shot. Cos 75 and sin 15 will be same. So this same value I'll get of sin 15 degree as well. Everybody got this? Any confusions if you have, please ask. Any queries if you have, please ask. I'll definitely respond. Yes or no? All the participants got this. Now there comes one more very crucial and important result, which is called tan of A plus B. Yes. This is something really amazing, important and crucial. What is this? Let's talk about this result as well. Here we are. Sir, we know sin A plus B. We know cos A plus B. So what was sin A plus B? What was cos A plus B? So imagine this, if I divide this by this. So on the LHS, I'll have sin A plus B divided by cos A plus B. Can I write it in a short? So sin A plus B is sin A. Sin A plus B is sin A cos B plus cos A sin B. I'm writing it in shorts. I hope it is understandable. Cos A plus B, I hope you do remember. It is cos A cos B minus sin A sin B. Yes or no? What if I divide the numerator and denominator? What if I divide the numerator and denominator by cos A cos B? Yes, there could be cos A cos B. So if I divide numerator and denominator by both cos A cos B, if I divide the numerator and denominator both by cos A cos B, don't you think something really good will happen? Don't you think something really good will happen? Sir, what is that good? Cos A cos B, sorry, cos B cos B, cos A cos A, cos A cos B, cos A cos B. I hope you do realize sin A upon cos A, that's tan A. Sin B upon cos B, that's tan B. This completely divides it. It is 1. Sin A upon cos A, tan A. Sin B upon cos B, tan B. So it will be tan A, tan B. What is that, by the way? So it is sin upon cos of the same angle. So we can call it tan A plus B. So one more identity added to your list. Yes or no? All the participants. Do let me know if there is any confusion, query or concern. Please respond if there are any doubts. Everybody getting this? All the participants, yes or no? So I think with this, one more identity gets added to your list. When you talk about tan A minus B, what do you think it could be? When I ask you tan A minus B, what do you think it could be? Sir, if you are asking us tan A minus B, if you are asking us tan A minus B, it will be tan A minus tan B upon 1 plus tan A tan B. Everybody got this? Everybody understood this? Any confusions if you have, please ask. Now, two more very important and crucial results are added here. What are those results, everyone? Pay attention. If I ever ask you sin A plus B, sin A minus B. So do you remember sin A plus B is sin A cos B, cos A sin B. Sin A minus B is sin A cos B minus cos A sin B. So imagine this. This is x plus y. This is x minus y. So x plus y into x minus y, you know the identity x square minus y square. So when you do that ultimately and simplify it by what simplification, sir? Sin square theta plus cos square theta is 1. So if you do that whole simplification, ultimately you land to this result, sin square A minus sin square B. I repeat, this is again one more identity. The proof I'm not covering completely, giving you the hint. This PDF you'll receive after the session for free of cost through our WhatsApp channel. The link is given in the description. And this identity, rather all of these identities with their detailed descriptive proofs and with a lot of results and questions will be there in this PDF after the session. Everybody got this? Everybody? And this is something JEE asks you. This is something JEE will ask you. Will be using it. If I see something like sin A plus B into sin A minus B, I will not hesitate in replacing it by sin square A minus sin square B. Or rather, if as per the need of the question, I may write it as cos square B minus cos square A. Everybody got this? Similarly, there is one more result which you need to remember, which goes like this, where cos A plus B into cos A minus B. Sir, cos A plus B is cos, there is a typo here. So let me just correct it. Hold on for a while. So this proof you would see me doing here. There is a small typo here. Let me just correct it. I think only this part needs to be changed. Rest of the things are great. So this part needs to be changed. Let me just make that correction. So cos A plus B, sir, cos A plus B we know is cos A cos B minus sin A sin B. Correct me if I'm wrong. Everybody do let me know if there's any confusion. And sir, cos A minus B is cos A cos B plus sin A sin B. Again, does it not look like x plus y into x minus y? This is x minus y. This is x plus y. That is x square minus y square. So it will be cos square A cos square B minus sin square A sin square B. If one of these gets replaced by 1 minus sin square B, and this sin square A gets replaced by 1 minus cos square A, and when you simplify this, here comes one more result, which is cos square A minus sin square B. So cos A plus B into cos A minus B is cos square A minus sin square B. Wait a second, students. It is not there. One more identity you actually create here by simply changing this into this. Cos square A can I write as 1 minus sine square A. Sine square B can I write as 1 minus cos square B, but with a minus sign, it will be minus plus. Yes or no? So this one and this one are cancelled. I am getting one more result. So that is cos square B minus sine square A. So do you get this? That sir here, this identity also has its two variants. Which two variants, students? So the first variant is cos A plus B into cos A minus B is cos square A minus sine square B, or cos square B minus sine square A, and as per the need of the question, I will use it whenever needed. Everybody understanding this part? Any concerns or queries if you have, please ask. I'll resolve it. Now comes few more very important and very crucial ones. Let's discuss them as well. So here comes the next one. Can you help me with sine A plus B? Okay, sir. Sine A plus B is given by sine A cos B plus cos A sine B. Can you help me with sine A minus B? Sir, sine A minus B is given by sine A cos B minus cos A sine B. What if I ask you to add both of these? To add both of these. Sir, if you add both of these, you will get sine A plus B plus sine A minus B on the LHS. Cos A sine B, cos A sine B are cancelled. Sine A cos B plus sine A cos B will be 2 sine A cos B. Everybody understood the proof? Yes or no? Please let me know if there is any confusion. Yes or no? Yes or no? The next thing, sir, from this result, if you subtract it, what are you saying, sir? Sine A plus B is sine A. Let me write this whole. Sine A plus B is clearly what? Sine A cos B plus cos A sine B. Sine A minus B, sine A minus B is sine A cos B minus cos A sine B. So what if I subtract it? So minus, minus, plus. And what if I add both of them? Sine A plus B minus sine A minus B. Sine A plus B minus sine A minus B. Do you see sine A cos B, sine A cos B are cancelled? So what am I now left with? I am left with cos A sine B, cos A sine B. So that will be 2 cos A sine B. Everybody understanding two more very important and crucial and insightful results which we'll be using. This is your first one and this is your second one. Everybody respond. Any confusions, queries or concerns if you have, please ask. Can I move ahead from here? The story doesn't end here. Actually, it begins. And with this, two more added to your list. Cos A plus B. Sir, cos A plus B, we know is cos A cos B minus sin A sin B. Mind you, students, there is a slight change. What is cos A minus B? Sir, cos A minus B is cos A cos B plus sin A sin B. So what if I add both of them? So if you add both of them, you'll get cos A plus B plus cos A minus B on the LHS. Sir, sin A sin B will get cancelled. You'll get 2 cos A cos B. You'll get 2 cos A cos B. So sir, one more identity added to our list. Yes, so keep adding all of these identities. Maintain a formula book. Maintain a formula book. Now, everybody getting this? Yes or no? All the participants, do let me know. Do let me know if there is any confusion. Do let me know if there is any query. Now, continuing further, here comes the next part where a lot of students make mistakes. Listen to me very carefully. There is a slight error here. Cos A minus B. Can you help me with cos A minus B? Sir, cos A minus B is cos A cos B plus sin A sin B. Do you remember that? And what is cos A plus B? Sir, cos A plus B is cos A cos B minus sin A sin B. Remember that? What if I subtract this one? So minus, minus, plus. And if I add now, so I hope you do realize cos A minus B minus cos A plus B. Cos A minus B minus cos A plus B will be cos A cos B, cos A cos B are cancelled. I'll get sin A sin B, which means 2 sin A sin B. Did you all understand this proof? Everybody do let me know if there is any confusion with this identity. I hope we are running at a good speed, at good pace. You are able to understand it. Any confusions or queries if you have, please ask. Any concerns if you have, please ask. Do let me know if there are any doubts. Should JEE aspirants watch it? Yes, if you are a JEE aspirant and if you want to revise Trigo, all the identities, it is a helpful. It is indeed a helpful session, students. So you must watch it if you really sincerely wish to revise all the identities of trigonometric chapter along with all the all the equations based formulae when sine theta is sine alpha, cos theta is cos alpha, tan theta is tan alpha, sine square theta is sine square alpha, and all of these great, important, really crucial results. Yes, it is important. Timing, I think we started at 6 o'clock and I may stretch it till 10 o'clock. So I hope that's fine. We'll definitely take breaks if needed. My friend, if you're asking for timings, there comes some more important and crucial results. Sir, look at or go back to this result. Go back to this result. Pay attention, everyone. From this result only, we'll derive one more very crucial or important result. Sir, what are you saying? Let me just help you in developing that here. Let us focus on this part again. Please pay attention, everyone. For a while, let's say I substitute a plus b by c and a minus b by d. So what happens? Can you add both of them? So sir, if I add both of them, b and b are cancelled. I'll get 2a as c plus d. So don't you think a will be c plus d by 2? Similarly, when you subtract this from this, you will get c minus d as 2b. So you will get b as c minus d by 2. Do let me know if you didn't get it. I'll re-explain. Everybody got this? Yes, my friend. PYQs I'll also bring, but this is majorly a backlog series which we are doing for our Arjuna JEE students who may have skipped this chapter because they might have joined us a little late. So those who have joined us a little late in the Arjuna JEE in English, this is a backlog session for them. Anyways, if you want to revise Trigo, this is a one shot which is sufficient for you. Questions, PYQs, everything is included. Yes, you decide when you should take a break. I'm your teacher or you're my teacher. So I am saying that now sine a plus b can be replaced by c. So sine a plus b can be written as sine c. Sine a minus b can be replaced by sine d. So that is 2 sine a. What is a, students? Sir, a is c plus d by 2. Sine a cos b. So what is cos? Cos is cos. B is c minus d by 2. So congratulations. One more identity unlocked. One more identity added to your list, which you need to memorize. Okay, sir. Shall we learn few more? Actually, a lot more. Look at this one. Look at this one. Look at this one here. Sine a plus b. So sine a plus b is c. Minus sine a minus b is d. Which is clearly 2 cos a. What is a, students? A will be c plus d by 2. Sine b. Sir, sine is sine. B is c minus d by 2. Everybody got this? So 2 more identities. Please add this. Congratulations, everyone. And the next 2 more, if I could add, I hope now it makes complete sense that you now realize that, sir, we know that in this identity, we make these substitutions that a plus b will be substituted by c, a minus b will be substituted by d. So based on this, c plus d by 2 will be a. I hope you are realizing it now. And c minus d by 2 will be b. So based on that, if I get more results, 2 cos a cos b. Cos a plus b, cos a minus b. What is cos a plus b? Sir, a plus b is c. Cos a minus b is d. So cos c plus cos d will be 2 cos a. What is a? C plus d by 2. What is b? C minus d by 2. Everybody got this result? Any confusions? Please ask if there are any doubts. Do let me know if there is any confusion. Yes or no? Yes or no? Yes or no? We don't conduct these classes regularly, but whenever they are conducted, we keep you informed. We keep you informed on our WhatsApp channel as well. So stay tuned, everyone. You can follow our WhatsApp channel to stay up to date. The link is given in the description, and you can subscribe and stay updated with our timings. So here, again, when I give you cos a minus b, sir, cos a minus b is d. Mind you, there is a slight change in this one. So pay attention, everyone. This is not that regular one. My friend, yes, this entire PDF will be yours at absolutely no cost. The link is given in the description. If you join our WhatsApp channel right after the session, we will be uploading this entire PDF. Yes, you can have the entire cheat sheet of the whole Trigo. That's what I was mentioning in the beginning only. So this will be cos d, because a minus b is d, and cos A plus B. So A plus B is C. So this will be C. Cos D minus cos C. Now with this is 2 sin A sin B. So 2 is 2. What is sin A? Sir, A is C plus D by 2 and sin B, that is sin C minus D by 2. Some people have this OCD that they don't appreciate it, like cos D minus cos C. So they take negative sign common. So they write it like cos C minus cos D, but that negative has to be adjusted somewhere. So that negative I push on the right hand side. I don't push it here, but if I push it here, I see a slight change here. This remains as it is, 2 sine C plus D by 2, but this part becomes sine is an odd function. So C minus D becomes D minus C by 2 because of that negative sign. Yes or no? I hope I have answered everybody's query or concerns. Any queries if you have, please ask. I'll re-clarify. Yes or no? With this, few more you get. Sir, how? Let's talk about this one. If I have sine A plus B, so what was sine A plus B, students? Sir, sine A plus B was sine A cos B plus cos A sine B. This is what? This is sine A plus B. Correct me if I'm wrong. Yes or no? This is sine A plus B. Yes or no? So, sir, sine A plus B when divided by cos A cos B. So, when it is divided by cos A cos B, when it is divided by cos A cos B, what does it become? Don't you think that one more identity gets unlocked? Sir, which identity now? I hope you do see cos B cos B, cos A cancelled, sin A upon cos A, tan A, sin B upon cos B, tan B. Similarly, with this, can you not prove this one? But do remember that there's a catch now. Actually, A and B are not just inputs to sine and cos, they are the inputs to tan as well. And tan strictly says I won't be taking any odd multiple of pi by 2. So I'll say I cannot take any odd multiple of pi by 2. Period of functions, I think I did already discuss, Vaishnav, my friend, when I was talking about graphs of sine, cos, tan, cosec, sec, cot. I told you sine, cos, sec, and cosec are periodic with period 2 pi. We did discuss tan and cot are also periodic functions with period pi. Remember that discussion we had while we were discussing graphs, domain, range, all those values. I hope you do remember that. So with this, when I continue further, we get some more results. What are they? Here comes. This one I hope is self-explanatory. If I ask you to divide sin A plus B by sin A sin B, I hope it is self-explanatory. Sin A plus B is sin A cos B plus cos A sin B. But sir, if you divide this result by sin A sin B, so if I divide this result by sin A sin B, if I divide this result by sin A sin B, do you get this? Sin A sin B are cancelled. Cos B upon sin B is cot A. Cos A upon sin A is cot B. Yes or no? Everybody understanding these results without getting confused, please let me know if there is any confusion. Now there are some more. So there are some more. Yes, there are some more. Do you remember sin A plus B? What is sin A plus B? Sir, sin A plus B is sin A cos B plus cos A sin B. But if I replace B by A, it will be sin A plus A, which will be sin A cos A, sin A cos A. So sin A plus A is clearly sin 2A, and sin A cos A will be 2 sin A cos A. So I think one more added to your list, that sin 2A is 2 sin A cos A. But for a while, let's say I am not happy or satisfied at this stage. I want to see some more things. So 2 sin A cos A, I multiply and divide by cos. So if I multiply it by cos, it becomes cos square A. If I divide it by cos, it becomes cos A here. The WhatsApp channel description, if you check, you will get link of the WhatsApp channel. So can you help me with sin upon cos? Sin upon cos is 10. So it will be 2 tan A. And what is cos square A? It is 1 upon sec square A. So can I write it as sec square A? And what is sec square theta? 1 plus tan square theta. 1 plus tan square theta. Do you remember that, students? So sec square A, I can replace by 1 plus tan square A. So for sin 2A, you get one more result. Which result? The result is 2 tan A upon 1 plus tan square A. Everybody getting it? Sir, does it mean that we can derive cos 2A as well? Yes. How? Let's talk about that result as well, students, shall we? Everyone paying attention here. So cos 2a if I want, cos 2a if I want. So what is cos a plus b? Sir, cos a plus b is cos a cos b. Yes or no? Minus sin a sin b. But if I change or replace b by a, I'll get cos a sin a, which is cos a plus a. Cos a plus a is cos 2a. Cos a is cos square a. And sin a is sin square a. So you get one more identity. Cos 2a is cos square a minus sin square a. Everybody understanding it? Now, if I say that sin square a is clearly 1 minus cos square a, but minus of this will make that plus. So it will be 2 cos square a minus 1. Yes or no? If I substitute cos square a by 1 minus sin square a, so it will be 1 minus 2 sin square a. So you get one more result. But there is one more. There is indeed one more. What is that, sir? Here, if I take for a while cos square a common. So if I take cos square a common, this will be 1 minus sin square a upon cos square a, which is 10 square a. If I write this cos square a as 1 upon sec square a, I hope that is also fine. And we know sec square a is 1 plus 10 square a. So this sec square a can be written as 1 plus 10 square a. So you get one more version. For cos 2a, there are 4. Which 4? Cos square a minus sin square a, 1 minus 2 sin square a, 2 cos square a minus 1, and one more, which is 1 minus 10 square a upon 1 plus 10 square a. The story doesn't end here, my friends. The story actually begins, and they add few more. Which ones? Let's talk about those as well. We know that cos 2a is 2 cos square a minus 1. Okay, sir. We know that cos 2a is 1 minus 2 sin square a. Yes, sir. Yes, sir. That's true. What if I take this minus 1 to the other side? So will I not have 1 plus cos 2a as 2 cos square a? Sir, can I not say 1 plus cos 2a divided by 2 will be cos square a? So my dear students, kindly add one more identity to your list. Kindly add one more identity to your list. Now, let us continue further. Pay attention, everyone. What if I do one more change here? What change, sir? If I take 2 sin square a on the LHS, cos 2a on the RHS. So, I'll have 1 minus cos 2a on the RHS and 2 sin square a in the LHS, which I can write like this. 2 if I divide both sides by, so 1 minus cos 2a by 2 will become sin square a. So, my friends, one more identity unlocked. Will you remember it? Everybody? 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 Yes or no? All the participants comfortably getting it? Do let me know if there is any confusion. Let's solve a quick question quickly, everyone. So do give it a try. This is a question which is an option-based question. So I'd like to know your responses. What do you get? It says cosec 10 degree minus root 3 sec 10 degree. How do we get it? Cosec 10 degree is clearly 1 upon sine. So can I write it as 1 upon sine 10 degree? This is minus root 3 sec 10 degree. Sec 10 degree can I write as cos 10 degree. Are you comfortable with this part, everybody? Are you comfortable with this part, everybody? Yes or no? So if I ask you something really direct, can I do LCM thing here? So cos 10 will multiplies here. It is cos 10 degree minus this is root 3 times sine 10 degree. Give me a quick response, everyone. Whole thing gets divided by the LCM, which is sine 10 degree into cos 10 degree. Everybody comfortable with whatsoever I've done so far? Yes or no? Now, what if I ask you to multiply and divide the numerator by 2? So, sir, if you're doing 1 by 2 here or by 2 here, technically, you're dividing the numerator by 2. So, multiply it by 2. One more thing I wish to do. Can I do the same thing in the denominator as well? So, can I divide the denominator also by 2 and multiply it by 2? Yes, we can. So, what happens if I do so? Let's see. Let's see. What happens when we do something like this? I hope some of you may have noticed that, sir, it gets converted into one of those identities which we have just learnt. This 2 stays like that, but here, this clearly becomes what? Sine 30 degree. 1 by 2 is what? Sine 30 degree. cos 10 degree is cos 10 degree, minus root 3 by 2 is cos 30 degree, correct me if I'm wrong, and sin 10 is sin 10 degree, so that is fine. Okay, that's brilliant. What is happening in the denominator, students? Can you let me know that? Sir, in the denominator, 2 sin theta cos theta, sir, that is sin 2 theta. So 10 degrees double will be 20 degree. Divided by 2 comes here in the numerator. I hope that's fine and understood by everyone. Yes or no, everyone? Do let me know quickly, everyone, if you're getting this. All the participants comfortably getting this. Sir, then what happens? 2 into 2 is clearly 4. Don't you think sin A cos B minus cos A sin B? What is that, students? Sir, sin A minus B. So that will be sin A minus B. So 30 degrees A, B is 10 degree. And in the denominator, this is clearly sin 20 degree. Sir, 30 minus 10 is 20 degree. So sin 20 degree upon sin 20 degree whole gets multiplied by 4. So 4 into 1, option D is our correct answer. How many of you got this? Do let me know if you got this answer. Nobody? Congratulations. It was a good question. Absolutely not. Easy question. Yes. But were you able to crack it? Yes. With this, 3 more identities are added to your list. Sir, can you share the proof? No. I'll give you the hint. You are intelligent enough. Can you help me with sin 2a plus a? Yes, sir, we can. Sin 2a plus will be sin 2a. Cos a plus cos 2a sin a. So I have given you the hint. I have given you the hint. If you just simplify this, you will see sin 3a as 3 sin a minus 4 sin cube a. Will you remember that? Will you all remember that? Will you all remember that? You want me to explain it from beginning? Okay, for you I will. What did I do? Cosec I wrote as, let me just start from beginning. Here I am with beginning. Cosec I wrote as 1 upon sin, sec I wrote as 1 upon cos, LCM I did. So I multiplied and divided it by 2 in the numerator. Same I did in the denominator. So what happened then was simply this, that this is sin A cos B, cos A sin B, which is sin A minus B. This is 2 sin A sin, cos A, 2 sin A cos A, which is sin 2A. So these were majorly the identities which I have used. So sin A cos B minus cos A sin B is sin A minus B, and 2 sin 10 cos 10 is sin 20 sin 2 theta technically. So that gets cancelled because this is and this are same. Ultimately, I'm left with 4. That's brilliant, students. I'm glad some of you are getting the answers. Now let's talk about something really crucial and important. 3 more identities unloaded or unlocked, whatever you call. So there comes the next one, sin 3a. What is that, sir? That is 3 sin a minus 4 sin cube a. That is 3 sin a minus 4 sin cube a. Which has one more variant, which is 4 sin 60 minus a, 60 degree, sin a sin 60 degree plus a. And I would humbly expect and assume that you remember it, because on this, JEE will definitely ask questions. Yes, JEE will indeed. The same result exists for cos 3a as well. Cos 3a is 4 cos cube a minus 3 cos a. Similarly, this identity also exists. 4 cos 60 degree minus a, cos 60 degree plus a is also cos 3a. For example, let me take an example so that I can make you understand this. Let's say I ever give you cos, let's say 10 degree into cos 50 degree into cos 70 degree. What do you interpret by this? Your eyes must be able to see something really simple, straightforward and direct happening over here. This cos 10 is cos 10. Cos 50 degree can I write as cos 60 degree minus 10 degree. Cos 70 degree can I write as cos 60 degree plus 10 degree. So what did we learn? Sir, if you multiply it by 4, although there was no 4, so I need to divide it by 4. We have just learnt this identity. That, sir, 4, although there is this 4 in the denominator which I keep outside. So do you remember 4 cos 60 minus theta in terms of degree, cos theta, and cos 60 degree plus theta is cos 3 theta. So this will be cos 3 theta. What is theta? Theta, I hope you notice, is 10 degree here. Theta, I hope you all notice, is 10 degree here. So 3 into 10 degree, which is 30 degree. What is 30 degree? Cos 30 degree, students, sir, that is root 3 by 2. So this will be root 3 by 4 into 2, that is 8. That is 8. That is 8. Yes or no? All the participants. I hope this was easy, understandable and doable. Well, there comes one more. Which one, sir? This one. Tan 3 theta, when you talk about, is also one of the identities, which is 3 tan A minus 10 cube A upon 1 minus 3 tan square A. Well, you get one more here. Let's say if you divide sine 3A by cos 3A. So don't you think it will be tan 3A? And if I divide this by this, so 4 and 4 are cancelled. Sine A upon cos A, that is 10A. Sine 60 minus A, cos 60 minus A, that is 10. 10. 60 degree minus A, of course this is 10A. Sine 60 degree plus A, cos 60 degree plus A will be 10 60 degree plus A. Everybody got this comfortably, all the participants. Do let me know if there is any confusion. So you get one more identity added to your list. Everybody, do give me a quick response if you are comfortable with whatever we are doing here. Any confusions, any questions, any queries, please ask. Shall I move ahead from here? Again, I'll say, don't forget these ones. They are some really crucial and important ones. IIT JEE will ask you questions based on it. Everybody, will you remember them? Will you all remember them? Yes or no? So with this, shall we do one more question? Everybody, look at this question. It is a very beautiful, very insightful, and very good question. But before we do this, let us take a quick break, a break of, let's say, another 10 to 15 minutes, and then we'll resume with the next part of this session. Everybody comfortable with the break? Let's take a small break. So a very small break I am taking. With this, I'm giving you this question as a homework question as well. Homework means the break question as well. So if you don't want to take a break, which you should not, you should take a break. You should hydrate, stretch, walk around, roam around, and then eat something and then come back. We'll begin with this question. So another quick break we are taking here. Everybody will resume after 10 minutes. Is that okay? So everyone, can you hear me? Can you see me? Can you hear my voice? If you all can hear my voice, come back everyone. We are resuming with this session again. I hope I am visible and audible. Everyone, give me a quick response. So the break is over. I'm sure you must have hydrated. You must have had some water. You must have had something, stretched, walked around. So if the system is still open, laptop, desktop, mobile phone, whatever it is, if that is still open and if you all can hear me or see me, we are resuming. Come back, everyone. Come back. So good to have you all again. What are we doing? Backlog series for class 11 students, Arjuna aspirants, our Arjuna batch students. The chapter is trigonometric ratios, functions, identities, equations, inequations, everything. Yes, with this one shot. So there is a question, a very good question, which says this upon this, this upon this. I think there is a typing error. First of all, sincerest apologies for making an error. This is not sine 9 degree. Apologies, my dear students. This is cos 9. Now, a lot of you say that is exactly why, sir, we were not able to do it. Otherwise, we would have done it. Otherwise, we would have done it by now, sir. This is the exact reason why we are not able to do it. So this, I am apologizing, is cos 90 degree. I'm really sorry for that mistake. I'm really sorry. So this is not sine 3 degree. This is cos 9 degree. No, this is sine 3 degree only. Sorry. This is sine 9 degree only. Let me just see what is the correction. 3. Yes, that was cos. So this was cos. This was cos. Yes, this is the correct question. Sine 3 cos 9, sine 9 cos 27. So triple and sine 27 cos 87. Yes, there was a small correction. Thank you so much, everyone. So how do we solve this? Has anyone done it, by the way? How many of you have attended it or attempted it and got the answer? Do respond. Give me a quick response. How many of you have gotten the answer? So this question here says something upon something. Let me just simplify one of these terminologies, not the whole question. Forget the whole expression. Let me just work on this. Sine theta upon, so this looks like cos 9 degree, which is triple of this. So can I say the denominator is like cos 3 theta? I mean the same is here. Sine 9 degree, cos 27, triple of 9. Sine 27, cos 87, triple of 27. So with that, this is a kind of expression which is almost getting repeated. This plus this with theta getting changed. So sir, can we simplify this? Okay. So if I simplify this, which means if I multiply this by cos theta in the numerator and denominator. So if I multiply by cos theta in the numerator and denominator, what happens with that? Sir, just multiply it by 2 in the numerator and denominator. What do you notice, students? What happens now? Sir, we notice that, sir, 2 sine theta cos theta is sine 2 theta. And the denominator is like that only, 2 cos 3 theta cos theta. Okay. Now, one more thing I'm willing to do here is this, that sine 2 theta, can I replace by sine 3 theta minus theta? Whole thing gets divided by 2 cos 3 theta cos theta. Now, sir, why are we really doing it? Have patience. Just listen to this. What is sine A minus B? Sir, sine A minus B is sine A cos B minus cos A sine B. Yes. If I divide this, this and this by this denominator, so 1 by 2 I'm keeping outside. 1 by 2 I'm keeping outside. There I have cos 3 theta cos theta. I have cos 3 theta cos theta. And there also I have cos 3 theta cos theta. Yes or no? Everybody, do let me know if there is any confusion. All the participants understanding whatever I'm doing. Now the next thing which I do is, do you notice cos theta cancelled, cos 3 theta getting cancelled. So this finally results into 1 by 2 times. 1 by 2 times whole of sine upon cos, that is tan 3 theta, minus sine upon cos, that is again tan theta. So this is what we get. What am I saying here is something really important and crucial, everyone. Please pay attention. What am I saying here is that sine theta upon cos 3 theta. I know something really important as an identity now. Sine 3 theta upon cos 3 theta is 1 by 2 times whole of 1 by 2 times whole of tan 3 theta minus tan theta. Tan 3 theta minus tan theta. Everybody understood this part? Yes or no? All the participants. Do let me know if there is any confusion with this part. Yes or no? So sir, how are you going to apply it? I think this is exactly what is given over here. This A, if I resolve, don't you think sine theta upon cos 3 theta, where theta is 3 degree here. So theta is 3 degree here. It will be 1 by 2 times tan 3 theta. So it will be tan 9 degree minus tan 3 degree. Correct me if I'm wrong. Did you all get this? Everybody? Yes or no? All the participants. Okay, sir. Same thing can I do with this part as well? Sine theta upon cos 3 theta. So that is 1 by 2. I'm keeping outside tan 3 theta. So that will be tan 27 degree minus tan theta, which is tan 9 degree plus. The same thing is happening one more time. Sine theta upon cos 3 theta. One more time we can apply this. So it gives you tan 3 theta. Half is already taken outside. So tan 3 theta, that will be 10. What is 3 theta, sir? 3 theta will be 81 degree minus tan theta, which is 27 degree. Everybody processed this idea. Everybody comfortably got this. Everybody understood it. Yes or no? Then what do we do next? I think, sir, we simplify it by cancelling tan 27 degree, tan 27 degree. And sir, few more things are getting cancelled. I think so. How? Tan 9 degree by tan 9 degree. Yes or no? So what are we left with? Sir, we are left with tan 81 degree and tan 3 degree. So I get the value of A as half of tan of 81 degree minus tan of 3 degree. That's A. Sir, luckily B is also the same, tan 81 degree minus tan 3 degree, but with half. So A is having a half here. So do you realize this tan 81 degree minus tan 3 degree is nothing but what? B. So I think we do have the answer now, don't we? Yes or no? Everybody please respond. What we get is, we get A as A, half as half, but this value is B. This is nothing but B. So what are we asked? B upon A. So B upon A, don't you think, will be 2 upon 1. That's 2. And this is your answer. Was it not absolutely straightforward, direct? But sir, there was a catch that this part we should be able to do. I get it. I get it. This is a slightly trickier part. But one thing should be added to your list of identities, that this. So one more identity unlocked. Will you all remember it, everybody? Will you all remember one more identity? So I hope you do remember, after this session, the entire PDF will get uploaded on our WhatsApp channel, from where you can download this whole PDF, which has all the identities of the chapter Trico. Yes or no, everybody? Shall I continue further? Now there comes something really interesting, straightforward and direct. This one. It is like that, domino effect kind of an identity. A student, one of our students, has called it domino effect based identity. What is this? Here. This is cos A. Forget this. Let me just take a very simple example. Let's say we have cos theta, we have cos 2 theta, we have cos double of 2 theta, we have double of 4 theta. Let's say these are the 4 angles I have. Yes or no? So here, if I just multiply and divide it by 2 sine theta. Can you explain the second slide, second point? Which, Vaishnavi? It's really tough for me to understand second slide, second point. Here, if you want sine theta upon cos 3 theta, I just multiplied by 2 cos theta in the numerator and denominator. 2 sine A cos B is sine 2A. Sorry, 2 sine A cos A is sine 2A. And in the denominator is very much sorted. Green tea aur pila dena. Okay, with this, I think the rest was simply an arrangement, an algebraic expression, which you know how to resolve. Now I'm talking about this part where, let's say, I'm taking an example first, then I'll come to this identity. So focus, everyone, pay attention. Something really beautiful will happen. So if I multiply and divide it by 2 sine A. So if you are multiplying it, sir, you should divide it. Okay, so if the original expression was what? The original expression was cos theta, cos 2 theta, cos 4 theta, cos 8 theta. I'm just wanting to tell you what directly can you write instead of doing this whole process. But I'll explain the logic so that you don't mug it, you understand it. So I'm multiplying and dividing it by 2 sine A. Okay, sir. So what happens there? Do you remember 2 sine A cos A? I'm really sorry. It should be theta actually. I'm really sorry. So it should be 2 sine theta. So this should be 2 sine theta. This should also be 2 sine theta. I'm multiplying and dividing by 2 sine A, 2 sine theta. So do you remember? So 2 sine theta cos theta, that's sine 2 theta. Remember that? So sir, this whole thing can vanish and I can replace it by sine 2 theta. Okay, sir. Now, do you notice if I multiply and divide it by 2, so multiplying it by 2, dividing it by 2. So again, do you not notice 2 sine A cos A? That is sine 2A. So this 2 sine 2 theta cos 2 theta will become sine 4 theta. So this will become sine 4 theta. Sir, again, if you multiply and divide it by 2, what happens? If I multiply and divide it by 2, what clearly happens is sine 4 theta cos 4 theta. That will be sine 8 theta with this 2. Don't you think so, students? Yes, sir, we do agree. So the numerator becomes what? Sine 8 theta. The numerator becomes sine 8 theta. Sir, one more time, I'll do 2. So if I do 2 one more time, so 2 becomes here, and this 2 cube becomes what? 2 cube becomes 2 to the power 4. This becomes 2 to the power 4. So again, 2 sine 8 theta cos 8 theta, welcome back everyone, will be sine 16 theta. So the numerator is resolved as sine 16 theta. So did you all understand something beautiful here? What, sir? I hope you do notice that here, if I have cos A, cos 2A, cos 4A, cos 8A, which means angles are in GP with a common ratio 2. Until the last angle is 2 to the power n minus 1A. So the final result you can directly substitute as sine of 2 to the power na divided by 2 to the power n sine A. Will you remember this result? Everybody. I hope this example is self-explanatory to make you understand this. Yes or no? Do give me a response if you didn't get this, all the participants. Well, there is one more very crucial and beautiful property, which is this. I hope you now remember this one, that when we talk about 1 plus cos 2 theta, so we do know that this is 2 cos square theta. When we talk about 1 minus cos 2 theta, sir, we do know it is 2 sine square theta. Remember that? Remember that, everyone. So sir, what if you divide this by this? So imagine this, 1 minus cos 2 theta is divided by 1 plus cos 2 theta. So 2 sine square theta gets divided by 2 cos square theta. 2 and 2 are cancelled. I'll get 10 square theta. So congratulations, students. One more identity added to your list. Kindly add it to your list and start memorizing it. Everybody with me. Any confusions or queries if you have, please ask. All the participants, understanding it or not, understanding this result or not, yes or no? With this, let us talk about something very beautiful and crucial, which they ask as some more important angles. Like sometimes you will be asked to figure out the value of sine 18 degree. Come on, sir, sine 18 degree. Yes. Few more very important angles there are: 18 degree, 36 degree, 54 degree, 82.5 degree, 72 degree. Yes, a lot more angles are there. Technically 7.5 degree, 15 degree. More angles will be added. Yes. So sir, how do we figure them out? Let's discuss them one by one, everybody. So if I'm interested in sine 18 degree, forget 18 degree for a while, sine 18 degree, let's focus on 18 degree. So can I say 18 degree as theta for a while? So what will be 5 into 18 degrees? Sir, that's 90 degree. So this will become 5 theta. Can I write 5 theta as 3 theta plus 2 theta? Yes, you can, sir. So what I do next is, can I take this 2 theta on the other side? So 3 theta will become 90 degree minus 2 theta. Everybody comfortable with whatever I've done so far? Yes, I will. Don't worry. By the way, I have said it. I have told you already. When I was talking about cos 75 degree, do you remember that? I told you the value of sine 15 degree as well. If you go in back there and visit that part, you will see we did discuss sine 15 degree already. So if I take sine ratio on both sides, this will become sine 3 theta. This will become sine 90 degree minus 2 theta. Now can you help me with sine 3 theta? Sir, that is 3 sine theta minus 4 sine cube theta. Do you remember that? We did discuss this identity. If you have forgotten it, I'll show this to you again. That here, sine 3 theta, we did discuss as 3 sine theta minus 4 sine cube theta. That's exactly what I'm asking you here. So with that result, if I ask you to apply that information here, you do get it as 3 sine theta minus 4 sine cube theta. Absolutely. So with this, I have this sine 90 minus theta is cos theta. So this will be cos 2 theta. Can I have everything in terms of sine? Yes, we can. What's the problem? We can. So if I convert everything into sine, first of all, is there any confusion regarding whatever I've done so far? Yes or no? Yes or no? So let us say I convert or write, I want to know the value of cos 18 degree. I can, the way we are trying sine 18 degree, in the same manner, cos 18 degree can also be found. Do you understand this? Let's say I want to know cos 18 degree. Let's say I want to know cos 18 degree. So in that case, what would happen is, sir, this will change a little. This will change a little. What change will happen? The whole process, the whole process. Did I do any mistake? I did. I was removing sine. Wait a second, everyone. I'll just remove it one more time. Sine, sine, sine. I am now asking you, what if I am interested in sine 18 degree? So what will you say? Sir, the whole process will remain same except for one change, that here you will take cos. So let's say if I ask you cos 18 degree, in that case, what will you do? Sir, to have that, I'll just take cos here and I'll take cos here. Do you all get that? Everybody. Do let me know if there is any confusion. Everybody. So sir, with that what happens is cos 3 theta is 4 cos cube theta minus 3 cos theta. Do you remember that? Everybody. And what happens to the other side? Sir, here it is very simple result. Cos 90 minus 2 theta. What is that? Sir, cos 90 minus 2 theta is clearly cos 2 theta. Yes or no? All the participants. Yes, I'll tell you that as well. Don't worry. I'll tell you both actually, but I'm just taking you both the approaches of telling you that even when they ask you sine 18 degree or cos 18 degree, how do you find them? I'm coming to that part, don't worry, but I'm just telling you a few more things. For example, when you talk about cos 18 degree, what is the complementary of 18 degree? Sir, 72 degree. So when you say cos 18 degree, you do work out sine 72 degree as well. Similarly, if let's say you have found sine 18 degree, you do work out cos 72 degree as well. Did you all get my point? Everybody processed this idea. That's what I'm talking about. So now I'm talking about this part where I'm saying that this is how, let's say sine 18 degree you want. Let me finish this part, then I'll come to cos 18 degree. Don't worry, I'll finish both. But just to save time in this one shot, can I directly prove it here with this already proven result so that we can save some time? But the initial part, I hope is understood by everyone. Theta we take as 18 degrees, so 5 theta will be 90. 90 is 90, but 5 theta I write as 2 theta plus 3 theta, so I write it as 90 minus theta and 2 theta over here. Everybody with me so far? Now, whatever you want, cos or sine, you just take the ratio. What do we want here? Sir, we want cos or sine. Whatever you want, I'll do both for you, don't worry. So let's say I want cos. So I'll just make one change here. 2 theta I'll write here, 3 theta I'll write here, just to save some time. So I hope only thing I'm doing here is this is 90 minus 2 theta and this is 3 theta. So I am saying cos 3 theta is cos 90 minus 2 theta, which is sine 2 theta. Everybody processed this idea. Do let me know if there is any confusion. Everybody. Now with this, what I say next is, pay attention everyone, cos 3 theta we know is 4 cos cube theta minus 3 cos theta. And what is sine 2 theta? Sir, that is 2 sine theta cos theta. Correct me if I'm wrong. Everybody do let me know if there is any confusion. Yes or no? With this, I think, sir, cos theta can be cancelled from both sides, because cos 18 degree is not 0, because cos 18 degree is something between 0 and 1, which is positive, which is non-zero. So cos theta can be cancelled. So there I get it as 4 cos square theta minus 3 is equal to 2 sine theta. Correct me if I'm wrong. Everybody processing it without getting confused? Do let me know. What did I just say? This is 4 cos square theta, this is 3, and this is 2 sine theta. Yes or no? Yes or no? Keep this result aside for a while. Wait a second. And keep this also result aside for a while. Just focus on this. Sir, can we do one more thing? For a while, can I just substitute cos square theta by 1 minus sine square theta? Yes, I can. So this will become 4 minus 4 sine square theta minus 3 is equals to 2 sine theta. So if I bring everything on one side, so 4 sine square theta I'm taking there, it becomes 4 sine square theta. This is plus 2 sine theta. 4 minus 3 is plus 1, but if it goes on the right hand side, it becomes minus 1. This is how the quadratic looks like. So if this is a quadratic in sine, Sridhar Acharya formula if I apply, Sine theta will be what? Thank you so much. Thank you so much. Sine theta will be minus b plus minus under root over b square minus 4ac. So 4 into 4, 16. 16 into minus 1 is minus 16. So minus of minus 16 is plus 16 divided by 2a, which is 8. Everybody got this? Now what I say next is, pay attention everyone. What I do next is, pay attention everyone, sine theta. Sine theta means, my friend, I have reached to sine 18 degree for you. I think it was SHA 45677. We are doing sine 18 degree luckily here. So I am saying that minus 2 is minus 2, plus minus is plus minus under root over. 16 plus 4 is 20. 20 is 5 into 4, which outside root is 2 root 5. So can I write it as 2 root 5? Whole thing gets divided by 8. But there is a catch. Sir, sine 18 degree should be unique. Should be something unique. So it should be either the positive one or the negative one. So which one do you think it could be? Okay, let's ask it to the graph of sine theta. So what do you mean by that? I am saying we know that graph of sine theta goes like this. So this is 0, this is 90 degree. So 18 degrees somewhere here. So clearly this is above the x-axis, which means on the positive side of y-axis. So it will be positive. Or already we know 18 degree is between 0 and 90, which means what? First quadrant. In first quadrant, sine is positive. So what I'll do here is, if I take 2 common, sine 18 degree, I'll receive as minus 1 plus root 5 by 4 or minus 1 minus root 5 by 4. Minus minus plus, but signature will be negative. Negative of 1 positive is negative. So this result will be discarded. The only acceptable value will be this. So sine 18 degree we have cracked. Sine 18 degree we have cracked is nothing but root 5 minus 1 by 4. Did you all get this? Sir, how do we crack cos 18 degree? Yes, very soon advanced level problems will also be brought. Don't worry. This is a backlog series which we are doing for our Arjuna students. So very soon we'll do a dedicated practice session as well on JEE mains and advanced level problems. So there, if I ask you cos 18 degree, sir, cos 18 degree, I hope you do know that sine square theta plus cos square theta is 1. So cos square theta is 1 minus sine square theta. So cos theta will be plus minus under root over 1 minus sine square theta. So sir, cos 18 degree will be plus minus under root over 1 minus sine square theta. So sir, 1 minus sine square theta will be something positive. Yes. Under root will take a positive value outside, but plus or minus plus. Sir, why? Because 18 degree is in the first quadrant, cos is also positive there. So I'll say whatever value I'll get will be my sine or cos 18 degree. Sine 18 degree we have worked out. This is cos 18 degree. Will you do the calculation by yourself? I have given you the hint. Can you do it by yourself now, students? So my friend who was asking for both, I think I have given you both, subtly, indirectly or directly. I hope this is how you can work out all of these values which are there at your fingertips. So with this, all of these values turn up like this, which we have discussed in a very detailed manner. I am really not able to discuss all of these here. If I could give you one more example, let's say you want to know, let's say you want to know a value like what? What value? Let's say sine 36 degree. Okay, let's find sine 36 degree. Sine 36 degree if you want. Sir, sine 36 degree, don't you think it will be sine 2 into 18 degree? So sir, what is sine 2 into 18 degree? Sine 2 theta. Can you help me with that, sir? That is sine 2 sine theta cos theta. Yes or no? Okay, sir. So 2 is 2. Sine 18 degree we have just worked out, root 5 minus 1 by 4. Cos 18 degree when you work out, which I'll show you with this table, but I will teach you someday, but don't worry. Cos 18 degree is given by root over 10 plus 2 root 5 by 4. I hope you got this. Root over 10 plus 2 root 5 by 4. So this value, if I replace here, I hope everybody is listening and understanding whatever I'm saying. So if I put it here, root over 10 plus 2 root 5, whole thing gets divided by 4. And when you simplify this, you get the value of sine 36 degree. So that's how you can work out all of these values which I have already given or kept here. I hope you got my point. Any confusions if you have, please ask. Any confusions? Sir, how do we find sine 15 degree, cos 15 degree? We have already discussed. Sir, how do we find sine 75 degree, cos 75 degree? We have already discussed. Sir, remaining, I will be giving you this entire PDF in which I have kept all the proofs, every single thing, all the proofs. But right now, since it is a one shot, I cannot discuss all of these. So right now I'm skipping it. But yes, you can get them at your fingertips when you go through it. Everybody, yes or no? Everybody. Sir, when are we going to get this PDF? Right after this session. Where? On our WhatsApp channel. Sir, where is your WhatsApp channel? On WhatsApp. But how do we get it? The link is given in the description. Coming back to few more things. Whenever you're dealing with a question like this, whenever you're given an expression like a cos theta plus b sin theta, remember it. It will always lie between minus under root over a square plus b square to under root over a square plus b square. What did I just say? I am saying a very simple thing, which I will explain with one of the questions. Here we have a question. I'm starting a poll and let's see. The previous poll I did not stop. So I think the option B was correct. I'm starting one more poll. Nobody is responding. So what is the point of doing the poll? Anyways, let's follow the process. So here we are. A question says the number of integral values of k for which the equation 3 sin x plus 4 cos x is equals to k plus 1 has a solution where k is a real number. Okay, sir. So I think, sir, when you talk about 3 sin x plus 4 cos x, we know something about it. What do we know? That, sir, a sin theta plus b cos theta clearly always lies between negative of under root over a square plus b square, which is 3 square plus 4 square, to under root over a square plus b square. Although you don't have to do it, you know Pythagorean triplet 3, 4, 5. So it will clearly lie between minus 5 and 5. So this expression 3 sin x plus 4 cos x will lie between minus 5 and 5. But sir, by the way, this 3 sin x plus 4 cos x is a value which is equivalent to k plus 1. So shall I not replace it by k plus 1? Yes, I can. So if I replace it by k plus 1, I think I have my answer at my fingertips. If I subtract 1 from all the three sides, minus 5 minus 1 is minus 6. This is k and this is 5 minus 1, 4. So sir, you are not asked all the values. You are asked the integral values. So what are the integral values? I hope you do know that. If you wish to write, it is minus 6, minus 5, minus 4, minus 3, 0, 1, 2, 3, 4. These are the integral values of k. These are the integral values of k. So 6 on the left of 0, 4 on the right of 0 and 0 itself. So 4 plus 6, 10 plus 1, 11 will be the answer. I am sure a lot of you have gotten it. Unfortunately, I started a wrong poll. Anyways, I'm sure you all must have gotten it. Yes or no, everybody? 11 was the correct answer. Everybody was able to understand it. Yes or no? Do let me know if there is any confusion. Now, let me begin with trigonometric equations. Let us talk about trigonometric equations. Listen to this part very carefully. This is the part which IIT-JEE claims that they have removed from the syllabus, but questions are asked. What is this part? Let's talk about it. Whenever I say that sine theta is root 3 by 2, what do you think? What comes to your mind? Sir, if sine theta is root 3 by 2, we say that, sir, sine theta will be sine root 3 by 2 happens at 60 degree. So we may say that theta is 60 degree, which is not bad, up to an extent true, but not completely true. This is not the complete truth. I mean, let me demonstrate it with a simple graphical approach. What we know about the graph sin x is, that it keeps going. It keeps on going like this. This is how the graph of sin x look like. So this is 0, this is 1, this is clearly somewhere minus 1. So somewhere here you get root 3 by 2. Yes or no? So if I draw a line parallel to x-axis passing through root 3 by 2, it gets drawn like this. So sir, this line intersects this curve sin x not only at 60 degree, but at some other angles as well. But at a lot of other angles as well. So sir, don't you think 60 degree was merely one of those answers? 60 degree was merely one of those values. So you may say that 60 degree could be an answer, but it is not a complete answer. So there we needed to bring general solutions. Sir, what do you mean by general solutions? Let's talk about that. So if I could begin with this basic idea that if I'm told sine theta is equals to sine alpha. So I can write it as sine theta minus sine alpha is equal to 0. I hope by now you all must have realized if somebody says sine theta is equals to sine alpha, then it is not necessarily true that theta will be alpha. It is a very bad practice because sine, cos, tan, cosec, sec, cot, they all are periodic functions in nature. So sir, there will be multiple values. So I just cannot say surely that this will be the only angle where sine will be this. So I need to get a general solution. So I'm talking about the general solution, everybody. Just give me a moment. So what am I saying here is that if sine theta is sine alpha, we say sine theta minus sine alpha is 0. So there, if I continue further, can you help me with sine c minus sine d? Sir, sine c minus sine d is 2 cos c plus d by 2. So theta plus alpha by 2 into sine c minus theta by 2, c minus d by 2, that is theta minus alpha by 2. Now imagine this. Process this, everybody. Process this, everybody. If you are ever told that product of two numbers is 0, that means either this is 0 or that is 0. So when do you see cos of theta plus alpha by 2 to be 0? Or sir, this sine theta minus alpha by 2 could have been 0. Yes sir, that's true. So sir, do you remember from the graph of cos that we did discuss it, that cos is 0 at any odd multiple of pi by 2? So sir, this angle theta plus alpha by 2 would be of this category, odd multiple of pi by 2. Or sir, sine is found to be 0 at any multiple of pi. I hope you do remember it. So here theta minus alpha by 2 will be of n pi category, where n is clearly an integer. Yes or no? Yes or no? Everybody getting this? Just let me get rid of some unnecessary elements who are unnecessarily visible to us so that I can focus on something more important, which is teaching here, so that I can stay focused and not get. So here this. I hope no confusion so far, whatever I've done on this, yes or no? So what I tell you here is that can you help me in simplifying this result? Yes sir, we can. Why not? So here if you see, theta will be given by, see this 2 and this 2 are cancelled. So theta will be given by 2n minus 1 times pi minus alpha. But sir, here if you look at theta, this I hope you realize 2 comes here. So theta will be given by 2n pi plus alpha. Everybody getting this result? Yes or no? So sir, don't you notice or see that you claimed that in both of the cases n is an integer? So if n is an integer, 2n pi will be odd. So this is odd multiple of pi minus alpha, which is theta. But here you are saying this is 2n pi. What is 2n? N is an integer, 2n will be even. So it is an even multiple of pi plus alpha. So sir, you are saying that if I get odd multiple of pi, subtract alpha. If I get even multiple of pi, add alpha. Can I write it in one single statement? I can. Sir, how? Let's see the beauty of mathematics coming into picture here. Theta, I am writing as n pi, multiple of pi. So sir, whenever n is even, alpha should be added. Whenever n is odd, alpha should be subtracted. You have this beautiful thing over here. Which is called minus 1 to the power n. Sir, what do you mean by that? I am saying that whenever n is even, don't you think it will be alpha added to it, because minus 1 to the power even will be plus 1. Whenever n is odd, it will be n pi minus 1 to the power odd minus alpha. So with this single expression, I have ensured that I incorporate both of these results. So what is my final conclusion? My final conclusion is that whenever you see sine theta is equals to sine alpha, you claim theta will be n pi plus minus 1 to the power n alpha. That's a general result, a general solution. Sir, based on this, do we see some more results? Yes, we indeed do. For example, what if I am told cos theta is equals to cos alpha? What do you think, sir? So cos C minus cos D I'll be using here. Remember that? Cos C minus cos D. Remember that, everyone. So sir, what is cos C minus cos D? I hope you do remember. It is 2 sine d minus c by 2, which is alpha minus theta by 2. Remember that? If you have forgotten this, let me remind you this by this result. I hope everybody has remembered it. This result I'm talking about, which we discussed in the beginning, which had a slight change in its version. Do you remember that? I'll show it to you so that you don't forget it. This result I'm talking about, where it is there. I'm really sorry. I made a mistake there. But anyways, let me just tell you the correct result so that I can tell you this. Cos C minus cos D I'm talking about. This one. Pay attention everyone. This one. Although we were right, no worries. So I'm talking about this result where I say cos C minus cos D. Either you use this one or this one, whatever. No worries with that. No concerns with that. Just pay attention this part. Cos C minus cos D is given by 2 sine C plus D by 2 sine D minus C by 2. Remember that? That's exactly what I'm using here. So if I bring that conclusion here in our result which I'm applying here, look at this. Cos C minus cos D is 2 sine C plus D by 2. What is C plus D by 2? Theta plus alpha by 2 into sine, mind you students, D minus C by 2. What is D minus C by 2? Alpha minus theta by 2. And this is equal to 0. Everybody getting this? Any confusions if you have, please ask. Do let me know if there are any queries or concerns. Yes or no. Now the next thing. 2 is 2, which is vanished. Something into something is 0, which means either this is 0 or that is 0. So, sir, are you saying sine alpha plus theta or theta plus alpha, whatever you wish to write, it is perfectly fine, by 2 is 0. Or this sine alpha minus theta by 2 is 0. Everybody processing this? Yes or no? Yes or no? Then, sir, what happens next is, I hope you do know that says sine is 0 whenever the angle is a multiple of pi. Whereas, I hope you do remember it. So, I'll say theta plus alpha by 2 will be in pi. Or I can say theta minus alpha or alpha minus theta, because sine is odd function. So, minus I can take common, push there. So, alpha minus theta or theta minus alpha, whatever you wish to write it as, you can. It is also n pi. Everybody processing this idea. Any confusions if you have, please ask. I'll re-explain, I'll re-clarify. Don't hesitate. So, with this, when I proceed further, I get few more results. Sir, what results? Pay attention everyone. 2 I push there. So theta I receive as 2n pi minus alpha. Or with this 2 if I push there, theta I receive as 2n pi plus alpha. So sir, can we club these two results into one? Of course we can. How? I repeat, if you look at this logically, don't you see? Even multiple of pi minus alpha, even multiple of pi plus alpha. So sir, theta will be even multiple of pi plus minus alpha. That's again a result. Whenever you see cos theta as cos alpha, you will say theta is 2n pi plus minus alpha. Did you all get this? Sir, if you talked about sin theta to be sin alpha, cos theta to be cos alpha, should you not talk about tan theta to be tan alpha? Yes, we should. So let's talk about one more conclusion where somebody says that tan theta is tan alpha. Okay. So something like that is given. Tan theta I can write as sin theta upon cos theta. Tan alpha I can write as sin alpha upon cos alpha. Cross multiplication, I hope you know, sin theta into cos alpha is equal to sin alpha cos theta, which if I bring on the LHS, cos theta into sin alpha is equals to 0. Sin A cos B, cos A sin B, so that is sin A minus B. So this is sin theta minus alpha is equal to 0. Sin is 0 when, sir, at multiple of pi. Any multiple of pi. So this theta minus alpha will be any multiple of pi. N is an integer. I'm not writing it constantly. So theta will be n pi plus alpha. So one more result added to your list, that whenever tan theta is tan alpha, theta is n pi plus alpha. Everybody getting all of these results? I hope nobody is finding them confusing. Everybody following whatever I've said so far. So first of all, these results which we have already discussed, you already know them, because where I was doing those graphs of sine, cos, tan, cosec, sec, cot, we did discuss these results. Do you remember them? Everybody, do let me know if there is any confusion. We did discuss whenever sine theta is 0, tan theta is 0, and sine theta is 0 at any multiple of pi, where n is an integer. Wherever cos theta is 0, cot theta is also 0. But sir, when is cos theta 0? At any odd multiple of pi by 2. Remember that? Similarly, sir, sin theta is 1 whenever you have 4n plus 1 kind of a multiple of pi by 2. But if 4n minus 1 kind of a multiple of pi by 2 you take, sine theta will be minus 1. Similarly, cos theta is 1 for even multiple of pi, at even multiple of pi, and cos theta is minus 1 at odd multiples of pi. This is a table which should be absolutely, totally, and clearly stored in your brain. If you're watching it, take a screenshot and keep it saved. Take a screenshot and keep it saved. Take a screenshot and keep it saved. By the way, sir, should we really take the screenshot? No, you should not. Why? Because after the session, whole PDF will be uploaded for you. Now, if I continue further, based on these results, I think we did discuss these very crucial results, where first one was this: if sine theta is sine alpha, theta will be n pi plus minus 1 to the power n alpha. The next result was this, that sir, we have already proved them. I'm just showing you these results again. If cos theta is cos alpha, then theta is 2n pi plus minus alpha. We have already proven them. I'm just showing you the result. Whenever tan theta is tan alpha, we know theta is n pi plus alpha. That also we have covered. Remember that, everyone. Any confusions or queries if you have, please ask. But the story doesn't end here. It actually begins with few more. So can I just directly show you these? So whenever you are given sine square theta is sine square alpha, cos square theta is cos square alpha, or tan square theta is tan square alpha, theta is only one, n pi plus minus alpha. How? Let me prove these very quickly. I'll not be writing them. I'll just show you the proofs, and with these only I'll prove them. So whenever I'm told sine square theta is sine square alpha, so sine square theta is 1 minus cos 2 theta by 2. Sine square alpha is 1 minus cos 2 theta by 2, cos 2 alpha by 2. 2, 2, 1, 1 are cancelled. So cos 2 theta is equals to cos 2 alpha. So whenever cos 2 theta is cos 2 alpha, sir, we know 2 theta will be 2n pi plus minus 2 alpha. So 2, 2, 2 cancelled. Theta is n pi plus minus alpha. I hope you're getting it. So sir, are you saying the same result will be true for cos square theta to be cos square alpha? Yes. How? You know that. This is now cos square theta is equals to cos square alpha. There is a small correction. Let me just do that, everybody. There is a small correction. Let me just do that. Hold on for a while. Everybody, please, please, please listen to me very, 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 very carefully. What am I saying here is that if I am told sine we have seen, now let me do cos square theta is cos square alpha. So cos square theta, I hope you know, is 1 plus cos 2 theta divided by 2. Cos square alpha can be 1 plus cos 2 alpha divided by 2. So 2 into 1 and 1 cancelled. So what I get is cos 2 theta is equals to cos 2 alpha. Now we have just discussed if cos 2 theta is cos 2 alpha, 2 theta will be 2n pi plus minus 2 alpha. So 2, 2, 2 cancelled. Theta is n pi plus minus alpha. The same result. Yes or no? Same. Can you prove for 10? Can you prove for 10? Shall I give you this as an assignment? So this one I'm giving you an assignment, and upload this single screenshot, the proof of tan square theta to be tan square alpha, after the session on our WhatsApp channel. By the way, all of these identities of this entire chapter will be uploaded on our WhatsApp channel after the session, once the session gets over. Don't worry about that. So far, whatever we have discussed, whatever we have done, can we summarize it based on these very quick results? Sine theta is 0. Sir, we know if sine theta is 0, theta will be n pi. If cos theta is 0, theta will be odd multiple of pi by 2. Sir, if tan theta is 0, theta will be n pi, because whenever sine theta is 0, tan theta is 0. Sir, if sine theta is sine alpha, then we know theta will be n pi plus minus 1 to the power n alpha. Similarly, if cos theta is cos alpha, theta will be 2n pi plus minus alpha. I'm making you revise it one more time. Sir, if tan theta is tan alpha, we know theta is n pi plus alpha. Now, 3 more results we have discussed. Which one, sir? Sine square theta is sine square alpha, cos square theta is cos square alpha, tan square theta is tan square alpha, then theta is n pi plus minus alpha. I'm going to, don't worry. Now, sir, these ones. Whenever sine theta is 1, theta is n, 4n plus 1 category of multiple of pi by 2. Whenever sine theta is minus 1, that is not written over here. So let me add it so that when you receive this PDF, you can revise it. Whenever sine theta is minus 1, we know theta will be 4n minus 1 category of a multiple of pi by 2, where n is an integer that I need not explain. And these results, cos theta is 1 for even multiple of pi, cos theta is minus 1 at odd multiples of pi. This is a very crucial result. Whenever somebody says sine theta is sine alpha, cos theta is cos alpha. Yes, don't worry. I will have patience, Ayush. I know what to teach, when to teach. I will take it. Don't worry. I will ensure that I take questions on it. This part is something really crucial. Let's talk about this part first. Let's say if somebody says sine theta is sine alpha, and along with this cos theta is also cos alpha. Okay, sir, you're saying this? Yes, I'm saying this. So this part says that theta will be n pi plus minus 1 to the power n alpha. And this part says, sir, theta will be 2n pi plus minus alpha. Let me rewrite this part. This n could be even or odd. So whenever n is even, it will be n pi even plus alpha. Whenever n is even. Getting my language? Yes or no? But if n is odd, it will be n pi minus alpha. When? Sir, whenever n is odd. Getting my language, everyone? But here in this case, please pay attention, everyone. Theta will be either 2n pi plus alpha or theta will be 2n pi minus alpha. Now, whatever I'm saying here is something really straightforward. Please pay attention, everyone. This says that whenever sine theta is sine alpha, with even multiple of pi, add alpha, and from odd multiple of pi, subtract alpha. But this part over here says, whatever you take, ensure that multiple of pi is even, and you add or subtract alpha. So what is common here between both of them? Sir, why common? Because I'm taking and. So I'll be taking the intersection. Remember that? So when you take and, actually, you need to ensure that, sir, common thing should be taken. So what is common? One says even multiple of pi plus alpha. It says even multiple of pi plus alpha. So that is common. So my first value will be even multiple of pi plus alpha. But this says odd multiple of pi minus alpha. And this says even multiple of pi minus alpha. So that is not common. This I'm not finding here. So this is the only thing which I find here. So whenever somebody says that sine theta is sine alpha and cos theta is cos alpha, then theta will be simply 2n pi plus alpha. Everybody processed this idea. Everybody understood this idea. Do let me know if there is any confusion. Now, those who were asking for a question, here is a question for you. Everybody give it a try. What does it say? The number of solutions of this equation in minus pi by 2 to pi by 2 only. So how do we solve this? Ayush, this is for you, my friend. Give it a try. Everybody, give it a try. I'm starting a poll because this is an MCQ. So let's do it, everybody. Shall we? Everyone, give it a try. Along with me, I hope you are having a sheet and a paper, pen and paper with you. You are also solving these questions. You are not just merely watching it. You are solving along with me. Because by merely seeing me solving these questions would not help. You need to do these questions by yourself. So this question, look at this. Sir, can we do one thing? Cos 5 theta by 2, can I push on the RHS? Yes. So on the LHS, it is cos 2 theta into cos theta by 2. On the RHS, it is 2 cos cube 5 theta by 2. I'll write it more properly so that it becomes visible. 2 cos cube 5 theta by 2 minus cos 5 theta by 2. Now LHS stays like that. Cos 2 theta into cos theta by 2. But from the RHS, cos 5 theta by 2 can be taken common. So cos 5 theta by 2 when taken common, it leaves you with 2 cos square 5 theta by 2 minus 1. Now, can you help me with one of the identities which you have already learnt? Can you help me with 2 cos square theta minus 1? Sir, we know it is cos 2 theta. Remember that? So this part stays like that. Cos 2 theta into cos theta by 2, yes or no, is equal to, this is cos 5 theta by 2 into what? Sir, into, this is 2 cos square theta minus 1, which is cos 2 theta. So this will be cos 5 theta by 2 into 2, which is cos 5 theta. Everybody got this? Any confusions? Okay, sir. Then what next? Okay. Then what I do is simply simplify this. Sir, how? Can I multiply it by 2 on both the sides? So if I take a 2 here, what am I saying is, do you remember that identity which we discussed? 2 cos c cos d. Let me just show this to you so that you can recollect it without getting confused. 2 cos c cos d, I want to show you in a while. Give me a moment. This is the identity which I'm talking about. Remember that? So if you ever see 2 cos C cos D, that is cos C plus D plus cos C minus D. Do you remember that? So if I could use that here in this question, I think I'll be done. Let me just show that to you, everybody. Here we have. So 2 cos C cos D. So that is cos C plus D. So it will be 2 theta plus theta by 2 plus cos C minus D. So that will be 2 theta minus theta by 2. Everybody got this? RHS also will have the same 2 cos C cos D. Everybody, yes or no? Just give me a second, everyone. Let me just get rid of some unnecessary elements who are just there to waste their life and time, of course. So 2 cos C cos D is clearly cos C plus D plus cos C minus D. So it will be cos C plus D, which is 5 theta by 2 plus 5 theta, correct me if I'm wrong, plus cos C minus D, which is again 5 theta by 2 minus 5 theta. Everybody got this? Any confusions if you have, please ask all the participants. 2 cos C cos D, 2 cos C cos D, that is 2, that is cos C plus D plus cos C minus D. I hope angles are correct. Yes. This is also cos C plus D, cos C minus D. Angles are correct. Yes, indeed, that's correct. So with this, when I proceed further, what I see is this is cos 5 theta by 2. Yes or no? This is cos 3 theta by 2. I hope calculation I can skip a little. This will be cos 2 into 5, 10. 10 plus 5, 15. So this will be 15 theta by 2 plus cos 2 into 5 minus 5 theta by 2, but minus 5 theta by 2 or 5 theta by 2, it will be same. Sir, why? Because cos is an even function. So cos of minus x is cos of x. Remember that? Good, good, good. Great, everyone. That's brilliant. So, sir, you do see something really excellent or exciting or good happening. Cos 5 theta by 2, cos 5 theta by 2 getting subtracted, cancelled. So, what am I now left with? Sir, we are now left with these two results. Cos 3 theta by 2 is equal to cos 15 theta by 2. Yes or no? Everybody do let me know if there is any confusion. Do let me know if there is any confusion. Any queries if you have, please ask. Otherwise, I'm about to complete this question in the next few seconds. Sir, how? Let's talk about that. So do we know that, sir, there is a general solution? If cos theta is equals to cos alpha, what do we say? Sir, we say theta is 2n pi plus minus alpha. Same logic I'll use here. Cos theta is cos alpha. So theta is 3 theta by 2 is equals to 2n pi plus minus alpha, which is 15 theta by 2. Everybody getting this? So to solve it, can I multiply it by 2 on both the sides? So this will be 3 theta, this will be 4n pi, and this will be plus minus 15 theta. If I take plus ones and if I take minus ones, so it will be 3 theta is equal to 4n pi plus 15 theta. Or the next solution will be 3 theta is equals to 4n pi minus 15 theta. Correct me if I'm wrong. Everybody getting this, whatever I'm doing here. Now the next thing, 15 theta minus 3 theta. What is that? Sir, minus 12 theta is equals to 4n pi. Sir, if you divide it by minus 12, 4 by 12, that is 1 by 3. So it is minus n pi by 3, where n is an integer. Remember that. Similarly here, 15 comes here. So it becomes what? It becomes 18 theta. It becomes 18 theta. Yes or no? Just give me a second. It will become 18 theta is equals to what? 4n pi. So theta will become what? Theta will become 4 by 18, which is what? 2 by 9. So this will be 2n pi by 9, where n is an integer. Don't forget this. So sir, is that the answer? No, 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 no. Stop. They did not ask you the general solution. They asked you particular solution, specific solution. They asked you the number of solutions in minus pi by 2 to pi by 2. So let me try certain values. Let me try n as 0. So if I try n as 0, this becomes 0. So one of the values of theta will be 0. Is this between minus pi by 2 to pi by 2? Acceptable. When I try n as 0, again I get 0. So I won't write it again because distinct elements I should be writing. When I try n as 1, so if I try n as 1, I'll get minus pi by 3. Minus pi by 3 clearly lies between minus 90 and 90. Sir, can I try n as minus 1? So if I try n as minus 1, I'll get pi by 3. That also clearly lies between minus pi by 2 to pi by 2. Now, if I try n as 1, it will give me 2 pi by 9. Sir, if I try n as minus 1, it will give me minus 2 pi by 9. Yes or no? Everybody getting it? Sir, can I try n as 2? Let me do this. So if I try n as 2, it will be 2 pi by 3. What is pi by 3? 60 degree. 16 to 2, 120 degree. Sir, 120 degree is more than 90 degree. So discarded. Similarly, if I try n is minus 2, I hope you're realizing 2 pi by 3. So minus 120 degree plus 120 degree beyond our range. So I'll stop using this. Now, if I talk about this, I have tried n as I think 1, 2 pi by 9. Can I try n as 3? Let's try it. So when I try n as 3, I'll get 2 into 3 pi by 9. So 3 pi by 9 is clearly pi by 3. What is pi by 3? 60. So 16 to 2 is again what? 120 degree. So there I stop because this is the final part which will be my answer. So I have gotten which values? 5 distinct and unique values. Option B would have been the correct answer. I'm sure some of you may have gotten it. Ayush, I think option B. Let me just recheck it. If you're saying option C, 7Y, option A, 7Y. Did you get some more? I think I should stop here. Did I miss any value? Because what did I try? Let me just check it one more time. If you are believing that 7 could be the answer. If I try n as 0, I got 0. If I try n as 1, 2 pi by 9 minus 2 pi by 9. If I try n as 2, yes, I'm sorry. I tried n as 3. I did not try n as 2. I missed it. I'm really sorry. So if I try n as 2, it will be 4 pi by 9. And minus 2 will give me 4 pi by 9. I think I missed these two. Let me just check it. So what is pi by 9? Sir, 180 degree by 9 is 20 degree. I hope you're getting it. Yes or no? So 20 degree into 4, 80 degree and minus 80 degree. So sir, 2 more answers will be there. Thank you so much, my friend Ayush, for correcting me. Yes, the answer will not be 5. I don't know. Mistakenly, I missed taking 2 because I was dealing with both of them simultaneously. So answer will not be 5. Sincerest apologies, students. Answer will be 7. Option A is correct. Very good, very good. Beautiful, beautiful, excellent. So Shivam, Ayush and Riddhi, that's brilliant. Keep it up. That's nice. Some of you have finally started responding. That's beautiful. Excellent. Keep it up, students. That's a good spirit, by the way. Very good, very good. I hope there is no confusion so far regarding whatsoever we have done. Everybody, yes or no? Everybody, yes or no? Trigonometric functions are so important in nature that you can solve some questions with the help of graphs as well. Let's say if I am dealing with a question like this, 10x minus x, where I need to find the number of solutions between minus pi and pi. So if I am asked a question to find number of solutions of this equation 10x minus x in minus pi to pi, what do you think the answer could be? I have just framed a question, integer type, timeless poll I'm starting. So sir, this question can be done with the help of standard approach. I would say don't even try, just use graphical approach. Sir, what is the graphical approach? Take it. So with this, what do we see? Everybody, please pay attention. If I could draw the graph of 10, how do we draw the graph of 10? So this is how we draw the graph of 10. Everybody notice this. So sir, this is pi by 2 minus pi by 2. This is pi, this is minus pi. So if we draw the graph of 10, how does it look like? 0 to pi by 2 like this, minus pi by 2 to 0 like this, and then pi by 2 to pi like this, and then minus pi to, I hope you know this, this is minus pi, this is minus pi by 2, this is 0, this is pi by 2, and this is pi. Okay, sir, we get this, but what next? Okay, what is next? Now, let us look at the graph of y is equals to x. So when you draw the line y is equals to x, it goes like this. It goes like this. So, sir, you were talking about the solution. So, I have taken two curves. One curve I have taken as 10x. Other curve I have taken as x. So, technically, instead of solving this equation, I am solving 10x is equal to x. So, 10x is equals to x. In minus pi to pi, what I did was, I drew the graph of 10x. I drew the graph of x. Everybody listening this? Yes or no? So there, what am I saying here is that 10x is equals to x is what I need to solve. So I draw the graph of 10x. I draw the graph of x. That means y is equals to x. I straight line making plus 45 degree with the positive x-axis in the anti-clockwise direction. And the graph of 10x we already know from minus pi to pi goes like this. So at how many points are they intersecting? Sir, first point is here. Then here they don't. Here they don't. Between minus pi to pi, they intersect at only one point, which is 0. So number of solutions they asked you will be 1. How many of you got this answer? Do let me know. So answer in this case would have been 1. I'm sure some of you may have gotten it. No worries. That's brilliant. Good. Keep it up. So I am done. I am done. So what did we start with? We started with trigonometric ratios. We talked about sine, cos, tan, and a lot of other results, right? Then we discussed the basic identities, and not just basics, but with the based on that, we created a lot of identities like compound angle formulae, sum, product, and all. The story didn't stop here. We then moved towards trigonometric equations, and we started learning general solutions, graphical approach, and all that. And with that, we have learned all of this. Now, what is my expectation from you? My expectation is only one thing, that after the session, this entire PDF you can get on our WhatsApp channel. So there, the whole PDF will get uploaded so that you can download it and you can revise the whole trigonometry. Yes, all the trigonometric identities, ratios, formulae, equation-based general results, everything is there in the single PDF. So this can be treated as a Bible for your revision of this chapter, trigonometry, indeed, for IIT-JEE. So this, you will find the link of our WhatsApp channel in the description. Sir, okay, so you're saying this PDF's revision is what we need to do? Yes. So first of all, revise this PDF, solve those questions which we have done in this. But sir, will that be sufficient? Absolutely not. Absolutely not. So sir, what should we do? First of all, go through the JEE Mains PYQs, JEE Mains PYQs of last 6 years of Trigo. Once you start feeling comfortable with those, move towards advanced PYQs of last 25 years. So that's my homework to you. If you really want to consolidate this chapter, strengthen this chapter, if you really want to get better at this chapter. If you have still any other queries or concerns left, do let me know. I'll resolve. Otherwise, this is the end of the lecture. Any confusions, concerns, or queries, if you have, please ask. Otherwise, we are calling it today. I'm still here for another 1 or 2 minutes. So if you have anything to ask, please let me know. I'm having my water. Just let me know if you have any concerns. Okay, so I believe there are no doubts, queries, or concerns. Shall we call it a day? Thank you so much, everyone. It was a really nice session. You all have been a great audience. Thank you so much. Take a good care of yourself. Good night.